Hello, Internet.
Did I having a microphone counts as someone having a microphone?
We live already?
We are live.
All right. While we're waiting.
Okay, I have nothing
How
for.
does that look for banners?
Looks good.
Where's my mic?
He's on TV, dude, right there.
That's funny. I see what you did there. Great.
I'm gonna put Dave on one,
Okay.
And then I'll take two when you guys are done with news. Does that work?
Yep.
Sure, which one's two?
You.
Thanks.
Okay. It's not going to let me go in the chat.
Yeah, chat search broken right now. Colton's working on it.
Okay. So just regular chat then?
No.
No chat.
No, Colton is working fixing chat,
Okay.
I believe. Yes, Colton is working fixing chat.
Cool.
That's very nice of him, considering things are probably.
He's up to his ears in water.
Yeah. I would almost say don't even worry about it.
Yeah, he got his computer up and in a safe place.
Alright, whatever works. Alright, let's try the right ear today.
Don't put it in the wrong ear.
What's up?
Don't put it in the wrong ear.
No, don't put it in the wrong hole.
Sorry, dad
That's-
joke.
I mean, that's just bad practice.
I'm allowed.
You are?
Yeah,
Why? Because you're 40 now?
I'm a dad.
Oh, you're a dad. Ah, I see. I see what you're getting at. You freak. Yeah.
He's working it. He needs a couple minutes. 10 minutes.
Oh, this works a lot better. Oh my gosh. No, I'm not like yanking my ear. Sweet. Sweet.
Everyone's good with the new rundown stuff? Hi, Mike.
I have a rundown.
Hello.
Mike, you're good with the new rundown? No questions?
Mm-hmm.
Great.
Yeah, I think it'll work out just fine.
I really like it. And your I'm just moving closer so it's easier for him to hear me. Your idea of breaking out the news and doing individual segments was quite positively accepted this last week. So I think we'll try to do that again this week. Maybe make it a little bit better so I suck less introing and outroing those. But yeah, the community seemed to really like that and really appreciated those. So I think we'll continue doing that for the foreseeable future. It was a good idea.
I wasn't listening. What'd you say?
The community liked the broken out news items that we did throughout the week, so we're going to continue to do those. Click here. You want to see the regular click up here. Yep. And select tablet script viewer, and that will open up. And then you probably want to hit the gears. And just uncheck that last option. The gears makes life a little bit easier, and then you can use the larger area or the smaller area to make it bigger or smaller. For your preference.
Benny,
Yes.
I had a question.
Yep.
I don't remember what it was.
Oh, we know we should do a mic check with Dave.
Never mind. Yeah, never mind. I'm good.
You good?
Yep.
All right. We'll do a mic check so that when we transition in.
Carrie Ann, can I get a mic check, please?
Yeah. I actually have absolutely no idea how loud I'm going to be in any way, shape, or form. So we're just going to pretend that sometimes I'm going to be saying things like this. And then there's probably other times I'm probably going to say something like this.
Cool, thanks. Dave.
Dave can't hear you, but Dave, go ahead and what'd you have for breakfast?
What did I have for breakfast? Eggs. Omelet. One hell of an omelet.
One hell of an omelet. What was
Yes.
in the omelet?
Not much. It was just a little cheese, but I made it.
Oh, that's why it was one hell of an omelet. You good? More? A little bit more.
A little bit more.
For dinner last night.
Dinner last night. What did we have for dinner last night? We tried a new restaurant there in Tehachapi. It's called Steampunk. And
Good.
what did I have? I had a hamburger.
You're good.
It was-
Jared, please.
Hey, what's up, everybody? I'm here today, and I'm going to be talking about some cool things. Tim Russ was at Griffith last night, and he's an awesome guy. He played Tuvok on Star Trek Voyager. Yes.
Okay.
What's up?
I think it's the pot. You think it's the pot?
Of course, pot would be my problem.
Speak.
Hello. Is it me you're listening for? It is. So I'm just going to be talking. What did I have for breakfast? I had like a Jimmy Dean bowl.
I thought it was
Bacon. Good Lord.
I'm good, thanks.
So, don't
Space-
touch that pot during the show.
Right, Space Mike.
So an idea that I had was for the rundown, we could create an extra section after the comment section. And maybe we could like plan on having like an extra story or two in there if we decide if we want to get around to doing more.
Okay, thank you.
And I don't know, just an idea.
So, Mike, what I was thinking, that's a good idea, but what I'm thinking of doing, I mean, another extra story isn't a bad idea, but I don't know that we'll get to all the news stories. But if we do, then we're screwed.
We either need a time target or to intentionally do extra news stories.
I think we need to intentionally do extra news stories.
Yeah.
So maybe what we do is we should talk about this in After Dark, but I think what we need to do is lighten up the front. Yeah, what's the time?
4 minutes.
We might need to lighten up the load in the main news section and then push that load to a E section, like Space Mike was mentioning, so that we've got it. Yay, chat room's back up.
Excuse me. Oh, sorry. Battery swap.
Jared, you're breathing heavy.
I am.
God, no, all of a sudden you're loud.
Here I am. I'm not changing the volume of my voice either, so.
Yeah, but you're not going to talk at that volume.
Probably not. Probably going to be talking more about this volume because it's pretty awesome. So, just the usual.
with the way it goes, you know what's up.
Okay.
So, clearing out the host room.
All of that in my ear. Somebody recording?
Thanks, Ben. Do another mic check.
Hi, we're doing another mic check to see if maybe that's what the problem was. Was my shirt the problem? I don't know. I guess we'll find out, won't we? So,
Tell me something about your eclipse.
I thought that ancients were very dumb for being afraid of eclipses, but within the first 3 to 4 seconds of it going completely dark, I had a legitimate feeling of absolute terror, and it was amazing. And now I don't think the ancients are dumb for being afraid of eclipses. So there you go. I don't know.
2.
I don't know what the plural for eclipse would be. I guess eclipses. It's not like a Prius, you know.
Would it be eclipses?
I read what's
Eclipses.
potentially fake news, which is if we only have about 1 billion years of Earth life left before we're destroyed by like the sun or whatnot, that about approximately 90% of the full eclipses have already been done.
Yeah, that sounds about right.
All right. There you go.
It was interesting. The here in Arizona, one of the local native tribes, the Navajo tribe, still consider the eclipse sacred. And so when it was going on, I work with 2 people who happen to be Navajo, and they wouldn't look at it at all because it's this like sacred thing, and so they're not supposed to look at it or eat or drink anything during the 2 hours or so that it's passing by. And I found it really interesting.
Wow, that's a perspective I did not know about. So very cool.
I guess their whole mythology is that it's like a communication between the sun, moon, and earth, and because it's this cosmic connection that we need to stay out of it and just let them do their thing.
Interesting. That's
Yeah.
Ben, did you set up cameras for the studio?
I focused them.
Okay.
Is that what you're asking?
Did you set up 3 cameras?
Yeah, all 3. Yeah, you should have all 3.
Check. I didn't see it happen.
How
Yeah, I did it earlier. Yeah, you were working on rundown.
and 1800.
All right, we ready?
I'm ready. Everybody good?
Everyone ready?
rock and roll.
We are recording.
Oh, the format failed. Sorry. Now we have to awkwardly wait for the format.
Chat room saying that that we're no go.
Well, yeah, because we just did.
Oh, okay. We're redoing that. Gotcha. Whoa. Good Lord.
My computer has no Wi-Fi.
I had a problem with Wi-Fi today too.
I'm not seeing tomorrow.
Station 204 you're not seeing? Is that what you're saying?
Did it change?
Just station 204? I feel like it's been like that for a while.
Like that for the entire time we've been here.
Still broadcasting, so it's
I don't know.
all good, I guess.
I didn't have Wi-Fi.
We still have issues with the chat room, so we're just going to delay ever so slightly.
Okay.
Also, I'm still waiting for this format.
Do you have an ETA?
I don't know. I just came Colton saying, hey, I don't want to push too far, but
So I guess it's been officially announced that Representative Bridenstine is going to be the new NASA administrator.
Mm-hmm.
That's cool.
Yeah.
I mean, he at least he's a space fan and he cares, and he is, he's been on a lot of different space communities for both NASA and DoD space. So, he's at least knowledgeable on the subject and he's passionate about it. My whole question now, though, is because it's really unusual to have a serving representative, a serving congressman, take the job because NASA administrator is a full-time job. So I guess my question now is he still going to keep his congressional seat, or are they going to hold a special election to replace him? I don't know. Seems
Yeah, I guess
that's my question.
Guess we'll find out. Yeah, I don't know. I just briefly read that yesterday. I haven't seen anything further. But at least there's a nominee finally. So we'll see if.
And I mean, they've been talking about him for a while now, but yeah, finally there's an official announcement.
Yeah, I'm just wondering how long it's going to take to get him in, since Bolden took about 2 months to get in place. So, but we'll see. We'll see what happens.
Not only in, but up to speed and doing something.
Yeah, that too. So.
Whenever you change jobs, there's always a lot of learning that you need to do before you're effective.
Mm-hmm.
Space Mike, are you trying to speak?
No, I'm just practicing. I'm reading through one of my stories, but I muted myself so I wouldn't bother you.
Copy things.
Alright, I'm switching over to the Twitch chat room. Give me a minute.
Define switching over.
On the public chat, you don't need to do anything because our chat's working just fine.
Okay.
But the public chat is not.
Okay.
So I need to make it so that everyone else goes through Twitch. It will still show up in your chat room.
He's pushing TMRO.tv/live to the Twitch channel.
So, I know y'all are troubleshooting right now, but one other idea I had for something that we could possibly play around with in After Dark is, I don't know, maybe we wouldn't even want to do this or not, but I was wondering if maybe I could, on Skype, I could just change it over to show my desktop screen, and maybe we could play some Kerbal and go through like some basics and stuff like that for like, I don't know, 15 minutes or something like that. I don't know. It was just an idea I had.
First of all, stop second guessing yourself. Secondly, that's probably fine. Personally, I will be put on record. I have no interest, but that doesn't mean anything. So, you know, if that's something that, or we could do it as a monthly segment, or, you know, there's a lot of different options with that. I'm not against it in any way. I think if we're going to restructure After Dark, then it needs a new name at some point. If it's going to become more of an after show of sorts, then building more structure. Like if we want to build more structure into it, then we have to build more structure into it, if that makes any sense. And if we're going to do that, then I think it needs a new name, which is something I've been thinking about for a while. And then above and beyond that, if that's something that we want to do, which is totally fine, you know, that particular segment, maybe not every single week, but maybe once a month, or if there's something in particular you want to cover, but it's especially if it has something to do with like ISRO, like, you know, exemplifying that, I think is an awesome
Orbits and stuff like that.
Yeah, yeah.
Also, how far do you expect to get in KSP in 15 minutes?
No, I understand.
pretty
He's trying to keep it
experienced
shorter.
player.
He
I
doesn't
can
want
get
to
us
take over
pretty
the
far.
whole segment, and I can appreciate that for what that's worth.
And I guess that's why I hesitate mentioning, because I guess I don't want, other than like these extra news stories that we're trying out, I don't want us to have structure and have plans for After Dark so that it's still just an informal cool down for us. I don't know.
I'm good either way, honestly. That doesn't really faze me for the most part. But, you know, we've always had a little bit of structure because previously we've had to do the open and After Dark. Now we want to incorporate some extra news items, which is totally fine. Not to toot my own horn, I feel like I had a hand in that to start. So, I mean, I'm not against it in any way, shape, or form.
10 after.
Ben's talking, that's why we stopped talking. Sorry, Mike, in case you can't
No,
hear him.
it's okay. I can barely hear him.
Yeah.
Here's the deal, everyone. I'm having a hard time embedding the Twitch chat room. It just doesn't want to embed correctly. But I do want to keep the live chat going. So if you head over to Twitch, just go to twitch.tv/TMRO, or if you go to twitch.tv/TMRO/chat, the /chat will bring up just the chat room, so you can actually watch it on YouTube or wherever you still want to. That will get you back into some semblance of a chat room, and we can actually see the Twitch chat on our side. So if you guys wouldn't mind moving over there, my apologies. We'll work on the tomorrow chat room moving forward, but hopefully that'll get us in a place that we want to, that we're okay in being. We'll give you just an extra. By the way, I'm recording, so the deck is good. Anything else that we're working? Otherwise, we're pretty good.
Yeah, I'm good.
So we could suggest YouTube chat instead of Twitch.
YouTube chat doesn't integrate into our systems, and that is unfortunately that is a limitation of their technology. YouTube doesn't have a way for us to pull bidirectionally right now.
Colton says main chat is fixed. Just said it right now.
Is up? All right.
All I know is 4 sentences ago. That's what Colton said.
Chat.tomorrow.tv works.
All right. I have to undo what I just did.
Cool. Give us a second, guys, to undo whatever Ben has been just bestowed upon us.
And that's how badass Colton is.
Yep. Colton's doing it. Well, he's got wet ankles.
I was gonna say, literally swimming right now.
Colton's like got a floaty with a laptop on it.
I was gonna say, we'll try to keep the show short because he's got that computer above his head right now.
Sort of.
Awesome visuals, Jared. Thanks.
You're welcome.
Alright, room's up,
All that improv paid off.
Okay, everybody, you should be good on regular avenues of tomorrow chat.
Let's try this again.
Everybody ready?
Go.
Welcome to the conversation. I am Carrie Ann. I'll be your host for this segment. I, of course, have with me, I've got Jared, my astrophysicist, my astrophysicist, my resident astronomer.
I'll take it.
I'm just going to give you all of the astro names, and that's what you're going to have
That's
now.
fine with me.
Oh, goodness. And I also have Mike, our rocket specialist. And behind me, we've got Dutta, who's going to be producing the show. Thank you so much, Dutta. On today's show, actually, we have Ben, who's going to be talking a little bit later with Dave Maston, giving us an update on all things Maston Space Systems. But before that, we also have a little bit of news coming from a launch mishap, unfortunately, some Cassini news, and an all-new space shuttle. This is tomorrow, Orbit 1032.
Good morning. How's everything up in the sky?
Welcome back. Hello.
We're going to do all of that again, so we're going to go back to black and
Oh, okay.
yeah, we're
Just
starting
like,
from zero.
Sorry.
Mike. I know you didn't hear that in the beginning.
We're trying to tweak the intro a little bit. So give us a couple shots on the intro.
Welcome to the conversation. I'm Carrie Ann. I will be your host for this particular segment. With me, of course, I've got Jared, our resident astronomer. I also have Mike, our rocket specialist. And behind us, I have Adetta, who's going to be producing our show. On today's show, Ben will be talking with Dave Maston and giving us a little bit of an update on all things Maston Space Systems. But before we get to that, we do have some news, unfortunately, about a launch mishap. We've got some Cassini news and testing an all-new space shuttle. That's tomorrow on Orbit 10, Episode 32.
Good morning. How's everything up in the sky?
Welcome to the conversation. I'm Carrie Ann. I'll be your host for this particular segment. But with me, I've got Jared, our resident astronomer. I also have Mike, our rocket specialist. And behind us, of course, our producer of tomorrow, one and only Dutta. A little bit later on, Ben is going to be talking with Dave Maston of Maston Space Systems, so we'll be getting an update there. But first up, we've got, unfortunately, some news about a launch mishap, but then we've got some good news from Cassini and some interesting news about testing a brand new space shuttle. This is tomorrow, episode 10.32.
Good morning. How's everything up in the sky?
Of course, I want to make sure I give a huge thank you to our Patreon supporters. These are the people who are of the Escape Velocity supporters. These people, of course, are getting their names in the show. They get exclusive access to our Patreon-only hangouts, early access to After Dark as soon as it's available. The list just kind of goes on and on and on. You also get voting rights in some upcoming roundtable discussions, which I think is really exciting. So if you are interested in any of these things and more, head on over to patreon.com/TMRO. Oh man, so this was like an interesting week, and normally we would be covering launches in this particular segment, or this part of the segment. Unfortunately, we've got to talk a little bit more about a failure. So, Mike, tell me what's going on with ISRO and the PSLV failure.
Yeah, so the India's space agency, ISRO, they had a bit of a partial failure. I mean, the rocket performed kind of as expected, but, well, in any case, let's just go ahead and watch the footage of this, and we'll explain what happened and why this mission failed.
3, 2, 1, 0, plus 1, plus 2, plus 3, plus 4, plus 5,
So,
plus 6,
PSLV
plus
liftoff.
7, plus 8, plus 9,
PSLV
plus 10
liftoff
seconds.
normal with ignition of the solid core booster.
So this, as they said, is the PSLV, the XL version, which is the Polar Satellite Launch Vehicle. They launched this on Thursday, August 31st at 13:30 Coordinated Universal Time from the Satish Dhawan Space Center on India's east coast. But the payload did not reach its intended orbit. During the flight, the solid-fueled first stage and the 6 solid rocket boosters performed and separated as expected, and the second stage of the rocket, which is a hydrogen liquid-fueled stage with a single engine, also performed as expected and on time. But during the second stage burn, the payload fairing was supposed to have dropped away, but didn't separate at all, although they didn't notice it for a little bit. The third stage of the PSLV rocket, which is another solid-fueled stage, performed as expected, but with they didn't notice the extra weight of the payload fairing until the fourth stage of the rocket, another liquid-fueled stage, started burning, which has smaller engines. And you can even see the payload there, the IRNIS 1H navigation satellite, just bumping around inside that still intact payload fairing, trapped inside with no sunlight to be able to power its solar panels or even open them up. So IRNIS 1H, the Indian navigation satellite that was supposed to replace the first Indian navigation satellite, which has had some faulty atomic clocks, was put into the wrong orbit because of the extra weight of the payload fairing. Its highest point it reached was a 6,555 kilometer apogee and only 167 kilometer perigee when it was supposed to get into a geostationary transfer orbit and is eventually get into a geostationary circular orbit of 35,600 kilometers and to use the spacecraft's own engine in order to eventually get into that circular orbit. So even now, if they were somehow able to get the payload fairing off, there's just not enough fuel on board the spacecraft to get into that eventual planned orbit. So unfortunately, this mission was a failure, and they're probably just going to let it deorbit due to drag because of that really low perigee and just re-enter the atmosphere at some point. So hopefully that's a controlled re-entry. So really unfortunate about this news. And something that's really interesting is I did want to mention something from one of the top reporters at Space News tweeted out and reminded us that this launch failure is the first failure since the PSLV's first launch back in 1997. Since that first launch, which was a failure, they've had 37 successes since then, and it comes as the vehicle slated for an increase in the annual flight rate because they have lots of plans for their workhorse, the PSLV rocket. So really unfortunate about this, and I hope that ISRO is able to recover very quickly.
Yeah, that space is hard, and that's just kind of something that happens, which is a little unfortunate. Yeah. All right. So in also some slightly depressing, but also kind of good news, Jared.
Yeah.
I love the title of this one. Says the end is near for Cassini.
Yes.
So
it is.
why don't you fill us in on what's going on?
Today, actually, we're 13 days away from the end of mission for one of humanity's most spectacular voyages of discovery that we have ever put out there. And of course, I'm talking about the Cassini mission, which is currently in a series of orbits that is skimming the atmosphere and the interior of Saturn's rings. Cassini began these orbits in April, and it just finished its penultimate orbit before the final one, before the plunge that will occur on September 15th. Now, of course, Cassini always sending back beautiful imagery like this crescent Saturn with a hint of rings at the bottom and one of the moons in the background right there. Now, Cassini's actually in these orbits taking measurements of the mass of Saturn's rings. And that's because Cassini can now be non-influenced, if you will, by the gravitational pull of the rings, because it's going so close to Saturn that the gravitational pull of Saturn is overwhelming the pull of the rings. And knowing the mass of the rings helps us figure out their relative age, from which we can determine the origin of Saturn's rings. And actually yesterday, one of the project scientists on Cassini tweeted out that early results are saying that the rings are actually very young around Saturn, maybe about 100 million years old, which tells us that they most likely formed from a moon getting too close to Saturn and Saturn's gravity actually ripping the moon apart. More on that later, though, because that's just a preliminary thing that the data is showing right now. Now, Cassini has also been taking incredible images of Saturn's atmosphere, like we can see right here. We've not ever been able to get imagery this good of Saturn's atmosphere. It's about roughly 7 kilometers per pixel in this image, and we can actually see three-dimensional structure in Saturn's atmosphere as well. So. Great results that are coming out of this, and we're going to get even more as time goes on. Now, Cassini will be ending its mission early in the morning for us here on the west coast of the United States on Friday, September 15th. It's going to plunge into the atmosphere in order to prevent potential contamination of those moons of Saturn. It's going to be reconfigured on September 14th to basically send a constant stream of data via radio signals to the Deep Space Network here on Earth until it's destroyed about 60 seconds after touching the top of Saturn's atmosphere due to the heating that will occur as it goes in. The end of mission is set to occur, like we said, Friday, September 15th at 13:04 Coordinated Universal Time, or 5:04 in the morning here, Pacific Daylight Time. And it will do so just 1 month shy of 20 years of operation in space. Cassini was launched on October 15th, 1997, and spent well over 13 years at Saturn, which it did Saturn orbit insertion on July 1st, 2004. So it's just an incredible mission coming to an end. So much good data that we're getting from it just right now, and we're not even through half of it. And just what a way to end a mission, you know. That's just, nobody really thought about flinging Cassini through the atmosphere and the rings, that gap at Saturn, until a couple years ago when they decided to go ahead and do that. So, and it's just bringing back amazing data. So.
No, that's great. And yeah, the pictures are just absolutely spectacular. There's nothing like it out there.
Yeah.
That's awesome. Thank you, Jared. All right, so now, see, this is what happened. We started talking about a space shuttle. We got everyone really riled up, I'm sure. And I'm not sure I agree with that assessment. It is a space shuttle of sorts, but it's not what everyone is thinking. Mike, fill us in on Dreamcatcher and what's going on over there.
Well, we're actually talking about Dream Chaser. A lot of you guys are probably familiar with this already. Yes.
I'm so sorry.
That's okay. That's okay. So sorry to dash your hopes about a new space shuttle, but of course we're talking about the mini space shuttle, which is about 1/4 the size of what the space shuttle would be. And operations at NASA Armstrong have been ramping up lately as they're getting ready for their next glide test. So let's just go ahead and check out some videos of some of the stuff that they've been doing. Over the past few weeks, Sierra Nevada Corporation have been conducting successful tow tests at the runway at NASA Armstrong, which is co-located at Edwards Air Force Base in the Mojave Desert. Now, Dream Chaser in this video was towed up to a speed of 96 kilometers per hour, or about 60 miles per hour, and ensured the landing skid, the wheel brakes, and the aero brakes all worked and were able to slow down the vehicle to a complete stop. So, very cool. They've already done a test like this before, but just ensuring that this refurbished Dream Chaser was able to do it again. And this week, on Wednesday, this that you saw the tow test there was a couple weeks ago, but this week on Wednesday, Sierra Nevada Corporation tested their Dream Chaser prototype on a captive carry flight suspended beneath a helicopter. Now, that might not be so exciting, but there was a lot of important data that they needed to gather from this test. The captive carry was expected to test out all of their telemetry and control systems before the planned drop and glide test later this year. And during the hour-and-a-half flight, Dream Chaser and its tow helicopter helicopter made several high-speed and high-altitude passes to test out the ship's aerodynamics and simulate the conditions that will be needed during the approach and landing. Now, at least one more captive carry test like this is planned before the free flight, and that will, once they conduct the free flight successfully, that'll satisfy the last milestone of their CCICAP contract, the Commercial Crew Integrated Capability contract with NASA, as well as advance the development of the cargo version of Dream Chaser, which is going to be landing the same way under autopilot and will be returning experiments and hardware after a cargo mission to the space station. Now, the Dream Chaser cargo is going to be delivering cargo to the space station for the CRS-2 program, Commercial Resupply Services. And that's supposed to begin in 2019, and Dream Chaser's first mission for that program to the International Space Station is supposed to be in 2020. And they've already been contracted for at least 6 flights through 2024 using the Dream Chaser cargo. So I'm really excited for this. It might not be the crew vehicle that Sierra Nevada hoped to have when they first started with this, but at least it will fly into space at least 6 times. So I'm really happy to see progress on that.
No, that's really good. I think it was Wicket on Twitter was trying to figure out like why something hanging from a helicopter was even remotely significant. So I appreciate you explaining that to me because
Very important.
I kind of also
Otherwise,
had
it
that
doesn't
question.
seem that. Yeah.
Yeah, I feel like
Yeah.
we've had that technology to hang things from helicopters for quite a while now. All right, so goodness, Jared.
Yes.
You always bring us pretty pictures.
Yes, I want to bring some more pretty pictures.
All right, I guess I'll let you.
Pretty pictures of tiny things, I guess is, well, relatively tiny from our perspective on
Sure.
Earth, but actually really, I guess, scientifically ginormous. We used one of the most powerful optical interferometers that we have here on Earth to take an image of a star. Now, if you're wondering what an interferometer is, basically it's when we take the light from multiple telescopes and we use brute computing power to combine them together through some significant algorithms and an incredible amount of processing power in order to combine their light so that it gives you a resolution that you would get with a telescope significantly larger than the several telescopes that you actually have.
That makes sense.
So here what we used was the European Southern Observatory's Very Large Telescope. Again, we name things very well
Yes.
in science. And the Very Large Telescope is actually a collection of 4 8.2-meter telescopes. So we're already talking about some exquisite instrumentation here. So by combining their light, though, through interferometry, we basically made the equivalent of a telescope with a mirror 200 meters across.
Oh, wow.
So a big ol' honkin' thing. And we ended up pointing it at Antares, and this is what we saw. So this is the star Antares. Now Antares is a bright red supergiant near the end of its life, and it's only about 620 light years away from the Earth. And Antares' radius is so large that if you placed it where our sun is, it would actually stretch out into the asteroid belt, somewhere between Mars and Jupiter. Now, this team from a university in Chile took this imagery that is so detailed that we can actually look at the surface of Antares here. That is the surface of another star outside of our solar system, 620 light years away from us. And in addition to that, they were actually able to make out very precise motion of gas in the atmosphere of Antares. And this is very significant because one of the biggest challenges that we have in stellar astronomy, which is the study of stars themselves, is how exactly do stars lose so much mass at the ends of their lives? And this is an artist rendition from the European Southern Observatory as to what Antares may actually look like if we could get an image that clear. Now, this study showed that the same processes that drive the interior of stars, which is known as convection, is actually not driving the loss of mass at Antares. So this was a surprise, and this just is meaning that we need to do further study on this here. And I just, it's always really awesome that a lot of times when we set out to answer something about a question we have about the universe just completely throws us something unpredicted, like the fact that the gas isn't being driven by convection. So just some really cool results and some pretty pictures as well from the European Southern Observatory. So doing some great work in the Southern Hemisphere. So
Yeah, awesome.
Very cool.
All right.
That first image too reminded me of Venus. It almost looked like how blurry images of Venus look.
Yeah,
Very
like
interesting.
when you look at Venus in ultraviolet light, and you actually see detail in the clouds, because in regular, visible wavelengths, it just looks bland. So yeah, it's pretty exciting that they were able to do that, and I look forward to what they're going to do with other stars too now. So
That is really exciting. Oh my goodness, I love it. Okay, so we're going to take a little bit of a break. You'll get to see some calendar things of what's coming up, and then over the course of the next week. And when we come back, Ben is going to be interviewing Dave Maston of Maston Space Systems. Stay with us. We'll be right back.
Look into her face, the determination in her eyes. She won't give up or quit or fall for little fashion lies. Filled with awesome expectation, this girl's a fascination. And nothing in her way will keep her from her destination. 'Cause she's fire walking, she's fire walking. When it's hot, she keeps on moving, 'cause her heat keeps on improving. Yeah, she's fire walking, she's fire walking to be free.
And welcome back to Tomorrow. Now, before we get started with this segment, I did want to give a shout out to all the patrons of Tomorrow who have helped to make this specific segment of this episode happen. These are people who have contributed $10 or more to this specific episode. We also have our Orbital subscribers. These are people who have contributed $5 or more to this specific episode. To find out how you can help crowdfund the shows of Tomorrow, head on over to patreon.com/TMRO. All right, my name is Benjamin Higginbotham. I'm joined by the infamous Dave Maston yet again. Thank you very much for coming on the show. Kind of last minute. You're the Chief Technology Officer of Maston Space Systems.
Yes.
That's still the title, right?
That is still the title. I'm still CTO.
All right, so you were on about a year ago. What's changed in the last year for Maston Space Systems?
In the last year, we've actually grown a little bit smaller, mostly because XS1 came to an end for us. We did not get selected to continue on with it. Let's see what else has gone on. However, some technology we're working on for XS1, namely our engines, actually got picked up by NASA to continue work on. So our broadsword engine is continuing development. Let's see, other than that, we're still working on the Catalyst program. So that's a lunar lander that we're working on in conjunction with NASA as part of the Space Act Agreement. What else? And we've got a bunch of stuff that I just cannot talk about.
I feel like that's always going to be true on the show. You're going to be like, I can talk about this, but all of this other stuff we can't mention. Let's go back. You said XS1. That was the DARPA program for a single stage to orbit. It was single stage to orbit, right?
No, it was not.
It just needed to be
two
reusable.
Stages. It needed to be fully reusable. It was less than $5 million less than $5 million cost to do a launch. 3,000 to 5,000 pounds to low Earth orbit, and 10 flights in 10 days.
That's pretty incredible, right? I mean, I don't believe anyone's done anything even remotely close to that.
Yeah, well, that's why it's a DARPA program. No one's done that before, therefore it can be a DARPA program. And I think it's possible. I don't think it's possible by who they selected, but I may be biased.
Well, Neuropilot is asking, can you share your XS1 design?
To what extent? I mean, we had some interesting features about it. We have some patents pending from that, actually. So one of those is being able to take off and land in a cradle, basically leave the landing gear on the ground. The second thing, we have a very interesting aerodynamic arrangement for fins that allowed us to deal a lot with the aeroelastic issues of hypersonic flight in a really interesting way that gave us an ability to actually get to a fairly high lift-to-drag ratio for the reentry portion, and then work from there. Other than that, beyond that, we didn't. This was last minute, so I didn't get a whole bunch of details cleared. I can't just go on and on about it.
Can you talk about the cradle at all? Because that sounds kind of interesting. You said launch and land from a cradle.
Yeah, so from a cradle, it's just this platform, and the vehicle sits down on top of it, and you've got the hold down structure, and you can take off from it, and then you come back and land on it. You just don't need landing gear at that point. You just have 3 hard points on the vehicle, or 4 hard points, or however many, and it just touches right back down again. And that was enabled by the fact that we are able to land very precisely to within centimeters
Wow.
every single time. And because we're able to do that, we showed that we were able to scale that up and that we maintain the controllability as we scaled up. And it's like,
Well,
yes, we can do that.
That's a key thing, because right, I think of mass and spacecraft, and I don't think tiny, but they're not ginormous. You're not putting a human on board. So when you say scaled up, to what size?
So our current vehicles that fly right now are maybe 14 foot tall, 15 foot tall.
Sure.
XS1 was going to be somewhere in the neighborhood of 60 something or 70 something foot tall. Yeah, we're talking about a 3,000 to 5,000 pound payload, as opposed to, I think right now we're limited somewhere between 80 and 100 pounds, depending on details.
And even as you scale it up, you're still centimeter level accuracy.
Well, we were able to show that we can maintain the accuracy, yes.
Where is a launch and landing cradle useful, right? Because I also think of, like, we were first introduced to you at the Northrop Grumman Lunar Lander Express Challenge. I can now say it that fast. That's how often
Wow.
I've said that, right? Isn't that amazing? So that's when we were first introduced to you. So when I think mass and space systems, I normally think, oh, they're building landers for the moon. They're building landers for Mars. They're figuring out how to land in remote places that we've never gone before. But the moon does not have a landing cradle on it. Mars does not have a landing cradle on it.
Yet.
So, yet. Okay, but the first vehicles going there will not have landing cradles. So where are these useful? Or will they eventually go to someplace like the moon and Mars?
So, I mean, the first thing was, maybe back then I should have been a little bit more clear about the idea that we land anywhere and everywhere.
Sure.
And that includes Earth. So if you basically have any prepared place where you have an existing outpost or existing infrastructure, then part of that infrastructure could be a landing cradle. Just like airplanes require runways.
Sure.
It's just landing cradles take up a lot less space, require a lot less infrastructure surrounding it, and it becomes simpler. So basically, anywhere you have existing infrastructure, it becomes useful. So we start going to the moon. We return to the moon, and we actually stay there for any length of time, and we start developing some infrastructure that becomes useful. Likewise, with Mars, putting a colony on Mars, well, hey, if you put a cradle there, then all the weight that you would carry for landing gear can now go to payload.
So you have to first get the cradle there, but once you've got the cradle there, all of that stuff, the landing legs, all that stuff is gone.
Yes.
And you just have the vehicle. And how much, rough estimation, how big of a deal is that? How much weight are we actually saving here per vehicle?
So typically on a typical airplane, you can figure anywhere from 3 to 8% of the hull.
Well, wait, that's an airplane, though. I mean, we're not flying airplanes to the moon or Mars.
Well, you're still touching down pretty fast, right? I mean, airplanes, it's so. I mean, even with a rocket-powered vehicle, you're still looking at and maybe that number isn't exactly the same, but you're still in the same rough order of magnitude, right? Somewhere just shy of 10%. Is generally where you're going to be looking at. That's quite a bit of mass.
Sure.
No matter what. Now, because we've left the landing gear on the ground doesn't mean we don't have still some structure that goes with that and still has to be accounted the same, but you still get some significant savings there. So.
We had taught, you said XS1, what were some of the lessons from that? Because you did this, you got the launch and landing cradle, but did you learn anything else from?
Well, I mean, we learned a lot of things. So our capability to do aerodynamics, just huge steps forward in terms of being able to predict what the aerodynamics are going to look like. And then part of the study contract we had was actually to take some of that stuff that we had developed, and we did all the CFD work on it, and one of our aerodynamicists really just knows CFD really well, and worked with a company. We actually got him from that company via other whatever. But anyway, he works with a specific company, NUMECA, and the NUMECA CFD package is just really good, really powerful, and he was able to really bring it forward and get it to work on the vehicle aerodynamics. And then towards the end of the contract, we actually had a chance to go into a wind tunnel and check it out, and make sure that see if the wind tunnel said that our CFD was good. And very, very good prediction capability of the CFD. The CFD in the wind tunnel numbers just line right up on top of each other.
CFD being, I normally think like fluid dynamics.
Computational fluid dynamics, yes.
So just making sure how things are interacting with the vehicle.
Yeah,
the wind
so
and the air.
it shows you how the airflow interacts with the vehicle, how much lift you're getting, how much drag you're getting, and all sorts of details that the aerodynamicist can go into, and I'm like,
It's a little bit of like black magic of like, oh, I don't understand it. That looks more square and it's more aerodynamic. I don't
just
understand.
give me the coefficients I need so I can understand the controllability, and I'm okay.
So speaking of controllability, you mentioned fins. Are they fixed fins? Are they controllable fins? Like, what?
So it's sort of a weird. It's if you imagine you got the body here, the fins are like this, and we call them box fins. So it's basically like a diamond shape.
Okay.
Or think of it like a biplane, but the ends of the wings come together at the tips, and they're more wing-like in that we have elevons as part of the back tail surface of the wings themselves, or the fins.
So that doesn't help you in space, I assume. And that really doesn't help you too much on ascent, does it? That's more for coming back.
Does pretty much nothing. Does absolutely nothing in space. We actually were choosing probably not to use them on the ascent, except for maybe a little bit of trim work. But then on the way back, that helps a lot because that allowed us to do a lot more. We use a combination of rocket boost back and glide back, save a bit of propellant by being able to at least have some of that as a glide back. And we are able to show that we could actually save a little bit more propellant than while still carrying the extra weight.
It's an interesting trade-off, right?
So it's you have the extra weight, extra dry mass,
Yep.
but since it's a booster, we were able to actually show that we actually saved more propellant, and we were able to get more mass by having the glide back as opposed to the straight.
It's gonna be fun calculations figuring out like where, like there's a tipping point on that scale, right?
There is, yeah.
Yep, absolutely. So you'd also mentioned the broadsword engine, but that's not dead, right? You said that was picked up by NASA.
NASA picked that up as part of a tipping point contract, and so we're continuing to develop that. And it's just to go back on the XS1, the engine we came up with was we needed a 60,000 pound engine, highly reusable, LOX methane. And under the contract, then we got part of the XS1 contract was demonstrate a scale of that, a subscale version of that. So we developed a 25,000 pound version of the broadsword, all aluminum engine, all additively manufactured, LOX methane, and so and we basically did a test chamber assembly. We were able to do some testing under DARPA of the injectors and figure out the injector work and some of the cooling channel work. And now with Tipping Point, we're able to take that next step farther. We did some testing. We need to do more testing. We needed to do a few more iterations. So NASA's Tipping Point has helped us be able to start doing some more iterations and also look at some really weird material things that we can do with additive manufacturing.
Yeah, let's talk about, well, first off, are you still subscale on your test, or are you working up towards that?
So we're working now on that. The engine itself, we're working on a 25,000 pound version.
Sure.
And because we did not get XS1, we're like, okay, well, let's scale back to something a little more appropriate to the size company we are. And a 25,000 pound thrust engine, we believe, has more application to the stuff we want to do, to the market in general, because, well, 25,000 pounds seems to be a nice place to be for various engine.
All right, now let's laser focus on additive manufacturing, which is, there's a pun in there. So you said, you kind of just nonchalantly said, oh, additive manufacturing, the whole engine, which means, for those who don't know, you are 3D printing a rocket engine out of metal.
Yes, we are 3D printing a rocket engine, mostly out of aluminum. We have some other materials for various components of it, but yes, we're pretty much 3D printing the entire thing.
Tip to tail, the whole engine.
The whole thing. Yes.
So, and how is that, that's fairly incredible, and it seems like that's all the rage in aerospace right now, right? You got
it is.
I know that they're doing that on Space Launch, well, no, they're just doing components for Space Launch System. They're not doing the whole engine. But you've got other companies that are working on doing basically the same things. What are the advantages of additive manufacturing, and what are some of the disadvantages of doing it?
Well, some of the disadvantages, the biggest disadvantage seems to be it takes forever to get a piece built right. There's a critical thing there. Piece built right. And we've found that there's some design things that you have to worry about that you don't have to, So it's wonderful and great. Normally you think, okay, well, normal subtractive manufacturing, putting it on a mill or a lathe, you have to think about how you're designing, and you have design limitations about what the machines can do. Ooh, and so, great, additive manufacturing, we can do all these cool things, we can do things you never thought of before, and, well, yes, but now there's a different set of things that you can't do for various reasons. So we spent a lot of time going through designs and working with some of our vendors to figure out, okay, what can we actually do and make the designs actually work out. Turns out it's kind of difficult to build a piece that has a big curve where it's sitting on like two legs, because there's nothing there to support it in the middle. So as you're adding the material and going and doing the layers, you don't have structural support, you just have powder bed below it. And so if you don't quite do it right, you don't have any structural support for it.
And then just collapses.
It will not meet tolerances at all. It gets ugly and everything else.
So there's some of the cons. What are some of the pros? Like why it seems like you have to relearn how to build everything if you're doing additive manufacturing.
Well, you have to relearn.
It's stupid slow.
It is extremely slow. It takes us something like a month to get a part. Now, to be fair, these parts are occupying the entire build volume of the largest machines doing this kind of stuff right now. So it takes a long time. The advantages, though, are we can do some interesting shapes that you can't do with other techniques. Cooling jet. So you think about the RL10 engine is built by taking thin tubes that are, about 1/4 inch, I believe?
Oh, I have no idea.
In diameter,
sure.
only 1/4 inch diameter. You take hundreds of those, and you individually bend them. And then you individually put them next to each other and braze them together until you create a full engine, the entire nozzle. It takes a very long time to do that. They're extremely expensive. And a lot of that is because you need cooling channels to cool the engine wall, because for some reason, rocket exhaust is hot.
Weird.
Weird, and it likes to melt metals. I don't understand. So you need these cooling channels, and that was a great way of doing it. And the RL10 is just a great workhorse engine, but it's expensive to build.
Sure.
With additive manufacturing, we can just manufacture the nozzle and put the cooling channels in it, and it's.
You could do interesting things because you can build structure inside of structure,
yes,
which you wouldn't normally be able to do. So you could do cool things with like flow and whatnot.
You can, yeah. There's some details I don't want to get into.
Sure, all right, that's fair. I'm just talking out loud. Dave just shuts down.
I can talk about some of this once we get the patent paperwork all sent in.
All right. But overall, you think this is how everything's going is added to. I actually called it direct laser metal sintering. You corrected me earlier, and that's actually a term from EOS, right? That's not
DMLS or whichever is actually, yes, an EOS trademarked term.
I had no idea. So additive manufacturing.
So additive manufacturing, we use a laser sintering process on metal. Is the common way of doing that. Yeah.
For people who don't know what this looks like, can you describe, because you got the powder, right? So what is the process?
So you've got this big boxy machine, and it's mostly computer and a bunch of electromechanical stuff, and you've got this box area. And what happens is you put a little bit of it puts some powder in, it swipes it with this thing that makes the powder perfectly smooth on top, and then laser comes down and just starts turning on and off, hitting each spot as it needs to sinter the two pieces of metal together. Now for aluminum, like what we use, that's actually causing a weld. For other materials, it's actually just a sinter. It's not a full weld, but it's still, holding together. Yeah, and so it's just, and then once it gets done with that layer, it brushes across another layer of powdered metal, and then
So you're building this thing up by taking metal particulate
Yeah.
and bonding it together, and you do it
Yes.
layer by layer,
layer,
by particle,
by approximately the thickness of a particle of the powder.
Just you layer. That's why it takes so long, 'cause,
Yes.
and it's not like the laser just goes boosh at once. It's like
Yeah, it's going real slow. It takes
Yeah.
forever to go across one layer, and then
is it going to get faster? Is it going to get bigger and better? I feel like we're still fairly early on in this.
I don't know if it's going to get faster. It will get bigger. Like I don't see any size limitation beyond what people actually need.
So how big of an engine physically are you making now versus how big do you think you could make it?
So right now we're building a 25,000 pound thrust engine. We actually had the plans put together for a 60,000, a little over 60,000 pound thrust engine.
Is it like that? Is it like,
So, it's about yay tall. Yeah, about
Sure.
yay tall. We actually built it in 3 segments for
Okay.
the thrust chambers portion of it, about yay big around.
That's a meaty
It's
engine.
fairly,
Yeah,
it's fairly hefty. So yeah, it's as far as size, I think it's eventually we're going to get to the point where size limitation is the same size limitation you have now. There's certain instabilities for very large engines of the Saturn V F1 class.
Sure. Well, okay, that's ginormous.
At somewhere around 1.5 million pounds, you're going to run into some limitations of combustion stability and
But that's
all that.
that's not an additive manufacturing issue. That's a
That's exactly it. Eventually,
So-
the machines are going to be big enough to build these things. I'm not. That's not a concern. It's just how long does it take to get there.
sure. So the limit of additive manufacturing is the limit of chemical propulsion. Is really what you're saying.
Yes.
Okay. And actually, Lur in the chat room is asking, how much mass are you saving using additive manufacturing? That's assuming, of course, you're saving mass.
I think we are saving mass. I think we're actually saving mass more by the fact that we're using certain materials, and we're doing some really interesting thing with materials than we are by additive manufacturing. The additive manufacturing, we might be saving a few %, but we're looking at putting Merlin to shame in terms of the thrust to weight ratios.
All right. We'll look back at this moment in the future. The internet's listening. They'll notice. They'll be like, all right.
But I mean, I suspect that the Raptor engine's probably going to put Merlin to shame as well when you finally get it that.
Well, that'd be a similar
figured
class,
out.
right? Because you said you're working Methalox, right?
Yeah, so we're doing Methalox. Yeah.
So
well, I
Merlin's-
wouldn't call it the same class because Raptor's a little bit larger.
Sure, but to be fair, so more of a similar design than say a Carolox engine, right? There, because Merlin's a Carolox engine, Raptor's a Methalox, so you're Methalox.
But
is that not a fair?
When you look at it in terms of thrust to weight ratios, basically as long as you're in some kind of hydrocarbon and oxygen, it really becomes a construction thing, not you're using that propellant or that propellant. Like the propellants aren't driving the mass of the engine.
So, and let me ask you this. It seems like Methalox engines are all the rage these days, right? You got SpaceX working on one. You got Blue Origin working on one. You're working on one. I'm sure someone else is working on one. And it feels like, even though there were studies done in, I believe it was the 60s, maybe even earlier than that, basically saying this makes a lot of sense, but then everyone moves to Hydrolox and Carolox. Well, Carolox in the 60s because it was like easier to contain, and then Hydrolox for the shuttle, and then like no one did Methalox. So why now? What changed? Why is everyone like, Methalox?
Well, I think the biggest change is that you have commercial players are the ones really developing it. You had a change, actually about a little over a decade ago, you had the change that, we're going to Moon, Mars, and beyond, and we can actually make methane on Mars.
Not on the Moon. Well, not as easily as on Mars.
So, but yeah, we're going to Mars, we can make methane on Mars, and we're not going to be able to carry all of our propellants. So NASA had some interest. There's some commercial interest. Point out that the Air Force is still working on Carolox.
Yes, they are. That's the AR1. AR1
yeah.
from Aerojet Rock.
Not only that, but a lot of the work being done by AFRL is still on, getting to the full stage combustion LOX-rich, Carol-LOX type engines that Russia's done so well for so long.
They really have. They have. Their engines are amazing.
Yeah,
their Carol-LOX engines are
and
world class.
And the U.S. Air Force is trying to catch up to that and trying to figure out, what are we missing that the Russians are doing? And then meanwhile, apparently the rest of us commercial operators are just looking at it like, actually methane has some interesting properties that we kind of like.
It is interesting that it seems like the old players are like, we'll stick with Carol-LOX, and all the new space players are like, neat, Methyl-LOX. That's kind of how it feels, right? Yeah. And it seems like, because you had Carol-LOX engines.
No, we didn't. We've never done Carol-LOX.
I thought you did.
No, we did. We did alcohol and oxygen.
Blue Origin had Carol-LOX. SpaceX had Carol-LOX.
Did Blue Origin have Carol-LOX?
Yeah, no, they had Hydrolox. I'm just going to stop talking. You're right. It was Hydrolox.
They actually started off with a hydrogen peroxide.
I never explained, for those who don't know, Hydrolox, hydrogen, liquid oxygen, Carol-LOX, kerosene, RP1, liquid oxygen, and Methyl-LOX, methane in liquid oxygen. You're always bringing your oxidizer with you because, no oxygen in space needed for fire. So, right? All right.
Yeah, it's helpful. You can use fluorine.
Actually, there are a bunch of different things you could use, although that would not be fun. All right, Citizen 55385 asks, would the 3D additive manufacturing process work on the moon or Mars, to replace key parts? So we go to the moon, we go to Mars, we're not going to be able to bring spare parts with us. Can we just bring a 3D printer?
Sure, I believe Made in Space is working on that right now.
Sure. But I mean, there are issues.
One of our former interns created this company called Made in Space, and
actually, this is pretty incredible, and it's a hard problem to solve, especially in microgravity, because you got potentially stuff floating around / outgassing.
So, well, now we get back to: are you on the moon, or are you just on a zero-G?
Well, all of the above, right? So microgravity station versus something like moon, which would help because you got a little bit of gravity.
You have enough to hold stuff down.
Sure.
And that's the important part there. It may actually be easier. One of the difficulties with the 3D machines that we have now on Earth is that you have to make sure there's no oxygen on that metal powder bed as you're hitting the laser with it for various reasons, including the fact that you're just basically going to create oxides of your metal as opposed to just melting the metal. That becomes easier if you have a vacuum.
Just open the door.
Little electron, open the door, a little electron beam comes, use electron beam instead of a laser, and you just melt everything together. It's not a problem.
Let's move on. You lost, let's see here, you lost Zero, and actually Glider Flyer asks, do you have any updates on what happened to Zero B? There was like a tweet, and you basically said, yep, it's gone. And that was all the more information we got.
We were finishing up some flight testing work as a part of the XS-1 contract, proving that cradle landings would actually work. And we
launch and landings, right?
Launch and landings. I mean, nobody doubted the launch part of it, right? Because that's the same as the shuttle hold down bit. Right.
Okay, that's fair, but you still have to have the bits and whatnot to get out of the way and still come back. So, yes, you're right, launching from a pad is fairly normal procedure, but having a universal object that can accept both launches and landings, I would assume affects both the launch and the landing.
It turns out it does, as a matter of fact, and it did affect our takeoff, and so we learned a lot of lessons about it, and unfortunately, as part of the lifting off of the pad, it lost its mind, essentially. It had some forces placed on the vehicle in directions that we didn't really foresee, and caused the control of the vehicle to be inverted.
Interesting.
Which means
we've seen what happens with a proton when that happens.
Instead of correcting for the fact that it's starting to tip the wrong direction, instead of correcting and bring it back, it made it worse. And
is that solvable in software?
Oh yeah, it's totally solvable.
So then, solved?
So it would. I would think that's solved, but we're not rebuilding zero. So.
But you would still build that into other software platforms,
But
right?
next,
Be like,
but next
okay,
vehicle, yeah.
I mean, that's learning experience, right? Go, oh, not something we foresaw. Solve it in software, added to other products. So speaking of not, obviously,
Well, we're also going to. So in reality, we're solving that in both software and in hardware because there were some hardware things about that were like, yeah, we didn't really like it.
How did that feel? Like you're watching Zero B, basically. I mean, I assume it was an epic moment, one way or another.
It was pretty epic. I mean, anytime you see something crash is usually pretty epic.
Spontaneous combustion, rapid unscheduled disassembly.
So we didn't have any of that actually. It
Really?
just sort of laid down.
Oh, interesting. But
Rapidly, but it just sort of laid down.
laid down.
It didn't. I mean, we didn't. We
That's
didn't
the
have,
shirt for the show. It just kind of rapidly laid down.
It rapidly laid down. It did not. It did not. Explode. There was no fireball. There was no. It laid itself down. The structure was cracked in a lot of different places. The tanks might be fine. We're not going to find out. We're not going to test it.
You're like, we out?
We're done with that.
So then what vehicles are you currently flying? Because you had more than just Zero B.
So right now we're currently flying Zodiac, is the only vehicle flying, and that's handling our NASA Flight Opportunities Program flights. Zombie could kind of sort of fly if we wanted to, but it's the Zombie brains are out of date, and so we don't have any replacement parts for them. It's the one bad thing about commercial off-the-shelf computers is every 3 years they're out of date, and you can't get another one. So there's some tweaking we'd have to do in order to make that work, and we could, but it isn't worth it right now. We got Zodiac. Zodiac's doing a great job.
So that kind of leans into one of the chat room questions a little bit, which is from Smokey Durg, which is, if you end up not being able to use a part due to an error or some such, or maybe, for example, it's too old or it's too new, can you recycle it and try it again? So would you take pieces from one vehicle and move it to another, or would you?
If it depends. If we have a crash, then we're not likely to reuse a part because we don't know what forces each individual part encountered, and so we don't know, is there maybe some. Well, to give an example, when we crash a vehicle, one of the things that can happen with the computer boards is that you will not see it, but there may be a delamination in the board, and that delamination may cause one of the traces to not connect correctly anymore, and now you're going to have some random bug that just shows up whenever that board's flexed a little bit.
You're going to have to deal with these issues in space too, though, aren't you? Right? Like
well, the thing is if you know that you haven't ever, when you know you haven't ever crashed it, then you know that it isn't going to be. So, but once you crash, then you don't know, did it experience some force that caused a problem?
Yeah, but I guess my point is,
so that's why we don't reuse anything that's been in a crash.
But wouldn't that be good testing for redundant brains and redundant systems on vehicles, reusing some crash components, so that, because when you go to space, you're going to have radiation ripping through your equipment, and it's going to do weird things, right? I mean, unless you rad harden that thing beyond belief, right?
Well, I mean, then you're looking at a different architecture, and yeah, you could probably. Well, I don't know that you'd use those parts because you look at other ways of doing the testing that might make more sense.
Yeah, because your errors may be different than.
But you can do other things to simulate those errors that might make more sense. Yeah.
Right. That's fair. All right. I think one of my last questions. You guys tweeted out not that long ago some of your e-pump motors, and I didn't think to grab the pictures for the show, but it's not. It's Mast in Space on Twitter, and you can go not back that far. So, what are e-pump motors?
So we're building some electric. We're working on some electric pumps. One of our engineers had a crazy thought. And
those are the best kind.
Those are the best kind.
Oh, yeah.
And he was like, we can get more power out of these motors than what the vendor says. Called up the vendor, walked him through his thinking. Took a little bit of time, and finally the vendor was like, you know what? You're right. We can get a lot more power out. We can really improve efficiency. We can do some pretty incredible things. So we managed to get a little, I think it's a Space Act Agreement kind of thing with NASA. I don't remember the exact vehicle, contracting vehicle, whatever, but we're working with NASA on this, and yeah, we're able to do some pretty interesting things. We've got the motor in-house. We're actually, most of the work right now is, I believe, on the test stand side of things, making sure we can test it as much as anything else.
Where would you use it? Like, why is that important?
So it's important for us because the engines that we currently use for Zodiac and Zero and all of that are small enough that turbo machinery is not worthwhile. Right? It's a little bit heavier, a little bit bigger, a little less, not quite efficient. At the smaller scale, electric pumps plus the batteries to power them is actually going to weigh less than a full turbo machine.
A turbo machine being like a turbo pump.
So turbo pump, yes.
Yes, and turbo pump, I liken that for people who don't know, calling it a jet engine inside of a rocket engine.
Yeah, exactly.
It's kind of a poor analogy, but it's the closest I can come up with.
Yeah, so basically everything in propulsion is turbo machinery with some kind of an outlet that determines whether it's a jet engine or a rocket engine.
And these are used to suck the fuel down.
So yeah, so
like,
basically you're sucking
fuel.
you're sucking the fuel down and you're spitting it out at much higher pressure, much higher flow rates than you'd get from the pressure and gravity alone. And especially when you get to space and you don't have that gravity for you.
And your E-pumps, how big of an engine do you think you'll be able to scale those to?
So the E-pump, we're actually working at a 5,000 pound thrust engine. And that seems to be about the sweet spot for what we're working on right now.
So your broadsword engine uses a turbo pump?
So broadsword engine uses turbo pump. We're using 2 turbo pumps, one for the oxidizer side and one for the methane side. And they're self-contained turbine and pump on each side, so we don't have to worry about interpropellant seals, and we don't have to worry about gearing between the two and all that. So
you're just pulling what you like. It's similar to what the Russians do. Is that correct? Or the Russians?
So I'm not aware of any engines that use dual expander that actually exist. I think there was 1 or 2, but I mean, I've encountered it only in books and classes as theoretical thing.
And it's working?
So far it looks good. It looks great, actually. Yeah, we put a little bit of oxygen and cooling channels at one. So part of the reason why people don't like doing it is you have to use your oxidizer as a coolant.
Okay.
And running oxygen through metal is generally frowned on for some strange reason.
Just too cold. Well, because it's trying to get out?
Because if it warms up a little too much, or if there's any particles in the flowing with the oxygen, you could start a fire with the metal.
An oxygen rich, with the metal!
So you get a hardware-rich combustion process going.
Yep.
So yeah, so we've done a lot. We've done a lot of testing with that, and because we're using the aluminum, the way aluminum oxidizes, it's fairly tame and it's fairly safe to use oxidizer and aluminum together. Which is really strange for where it is on the table of elements, but that's okay. It works out fine for us, and we were able to demonstrate that it's not a problem at all, really.
Dutta was great, by the way, and grabbed some images of the E-pump. So thank you, Dutta, for pulling it off. Yeah.
So yes,
cool, awesome. All right, so why don't we end there? We've asked you these questions before, but we're going to ask again. We'll compare and contrast your answers.
Okay.
Some of them I happen to know are not going to change, so I'm going to ask anyhow. But we'll see. Unless you're going to mess with me. The first question is: Moon or Mars first?
Moon first.
Yeah, I figured. Would you go?
Yeah. Well, yeah. Heck, yeah.
Yeah.
Love to.
When do you think humans will first land on Mars?
Not sure now.
Interesting. Why? What changed?
Well, for one, the leader in going to Mars seems to have changed his tune a little bit towards maybe stopping at Moon.
That was weird, wasn't it? That came out of nowhere.
No, it didn't come out of nowhere. That came out of D.C., I think.
Okay, that's fair. All right. Okay.
I think that came out of D.C. Yeah, and some of the political changes have been going on. Maybe that's I don't know. It's my best guess. But
what about
I don't
you?
know.
I mean, you've always said that you're going to scope out, right?
I still intend to, but I don't know. It's taking a little bit longer than I expected, and my joints aren't quite as free moving as they were. And
All right. So you've always been moon first. Would you just go kind of? Would you work to colonize the moon and then be like, all right, I've done my part, or would you always try to continue on to Mars?
I still foresee continuing on towards Mars. That's,
okay.
Yeah.
When do you think humans will step foot on the moon again?
Soon. Not soon enough, but soon.
Can you decade? More than a decade?
I can see a path for mid-20th century, so a little less than a decade.
Interesting. Now, do you think that'll be flags and footprints, or do you think that's colonization, or a little bit of both?
I think that's going to be early exploration that hopefully leads to. I don't think flags and footprints is going to work anymore.
All right.
Like you're going to have to be able to say, okay, I'm setting down and I'm actually doing something. May not be colonization, but it won't be colonization at first. But it might be industrial infrastructure. Lights out, building stuff.
Interesting.
We have manufacturing facilities that operate lights out right now. I think you're going to see more of that when you start working on the moon.
Oh, what's the moon? Moon. I think the movie Moon, if you've seen it, right?
That was close, but not quite. Yeah, there was one person there, but
was there though? All right.
One person over and over again every few years.
Spoilers, Dave. Spoilers.
Right. It's been out for more than 5 years.
Somehow I'm still going to get yelled at. All right, Dave. Last question. Why space?
Why space? Good heavens! I know I've answered this before.
Yeah, you got to see the answer's the same.
I mean, for me, it's just I've always been intrigued by it. I don't know.
Seems to be a passion of yours. I mean, you seem to be.
Yeah, I guess I'm just an altitude junkie, and that's the ultimate altitude, right? Best thing I can come up with, considering basically leave here and we're gonna go grab some food, and then we're going on vacation into the mountains.
I'll say you're a nature junkie. You're not just an altitude junkie. I think you're a nature junkie. And what better nature than the moon or
That's
Mars?
true. It's totally unspoiled. Yeah, exploration. Yep. Mm-hmm. Sort of an exploration thing there.
All right, Dave. Thank you so much for taking time out of your vacation,
Thank you.
Right? Yeah. I mean, I was like, Dave, help, and you're like, all right, cool. We're on vacation, but we'll pop down. I really do appreciate both of you coming down and taking time out of your vacation. So it was absolutely fascinating interview.
Well, thank you for having us.
All right, we're going to take a quick break. When we come back, comments from last week's show. So stay tuned. We'll be right back.
We've always looked to the stars. They guide us, give us comfort, help us find our way. We see ourselves out there. When we look up, it inspires us. And we long for something we don't yet know. We yearn to go there. So, we venture forth.
We choose to go to the moon in this decade and do the other thing, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills.
Tranquility Base here. The Eagle has landed. It's one small step for man.
The exploration of space will go ahead, whether we join in it or not.
Many think we stopped exploring. But we know our journey didn't end. We've only just begun.
Orion is functioning perfectly at this point.
Come with us and explore tomorrow.
And welcome back to Tomorrow. Now, before we get started with comments from last week's show...
Hold. No audio from you.
Almost. My bad. Better?
Yep.
Back to black.
From black.
Welcome back to Tomorrow. Now, before we get started with comments
Again.
from last week's show...
You
Sorry?
did it again. You're off.
Really?
Yes. I don't know how you managed to do that.
No, I'm not.
It's not.
I see. It's... Yep,
Oh,
I
you're not
understand.
clipped in.
No. It's frequency jumping. That's what that... I need to do... That, maybe? How apparent is that on camera? It's all right? Try again. And I didn't hear myself. And welcome back to Tomorrow. Now, before we get started with comments from last week's show, a shout out to all of the patrons of Tomorrow who have helped to make this specific segment of this episode happen. These are people who have contributed $10 or more to this specific episode. We also have our orbital patrons. They've contributed $5 or more. Or our suborbital patrons. They've contributed, $2.50 or more. They're going to get access to the name of the show, of course. They get Patreon Hangouts after dark as soon as available on demand, and early access to a copy of the show rundown. We're using new rundown software for this show. So it's kind of fun and interesting. So you get access to all those behind-the-scenes sort of things. To find out more information on how you can become a crowdfunding show patron of Tomorrow, head on over to patreon.com/TMRO. I'll just throw in all the words.
Every word.
Every word. Exactly. All right.
Oh, man.
You know, one interesting problem with doing this the way I did is I don't have the topic from last week's show in the rundown.
Oh. So last week's show, we had Representative Walker on the show to talk about the National Space Council.
That's right. Yeah, we're talking. Yep, it was a really great show. It was interesting to see kind of the thought process behind all of that and where we're going. So Capcom, take me away.
First comment comes from Doug Space. From tomorrow.tv, as I assume is how I'm reading this.
Yep. Mm-hmm.
Great.
Yeah, again, new rundown. So we're like, this is like we're used to.
Yeah. It says, I appreciate Representative Walker seems totally open about space transportation. It could be SLS commercial launchers, LEO or low Earth orbit assembly, and or nuclear rockets, whatever works out best, given that Falcon Heavy's November launch could be November launch, is that launch? Anyway, could be significant because it would be nearly as capable as a Space Launch System Block 1 at a fraction of the cost.
Yeah, my understanding, though, is that there's one space... So, interesting we're bringing up Space Launch System Block 1. Dave and I have I believe it's actually like a 1 penny bet, which then I expanded to $1, and then I think I expanded it to $10, and I think a steak dinner or something like that, without you knowing, by the way.
That's the worst part.
Yeah, right. And the bet being that I think Space Launch System will commit its engines to flight at least once. Do you still? And you're saying no. Are you still confident in your answer? You're still confident in his answer. All right.
There we go.
All right. So. But yes, the Space Council is interesting. I was a little disappointed to learn that, the number one thing I personally think it would be useful for is stopping this wild shift in strategy for NASA between presidents. As he mentioned, it really is, the Space Council will really be at the behest of the president, which means that as a new president comes in, that could shift. And really, it's not just the president, right? So the president sets it as does Congress. So, for the last 8 years, it seemed like the president and Congress were not on the same page when it came to NASA. We'll see, right? But
yeah,
as he mentioned, it does add another voice to the conversation, and potentially a powerful one. So hopefully that helps a little bit. Mm-hmm. You guys, your thoughts?
Yeah, I feel like with the addition of the vice president heading up the National Space Council, that does give it the political oomph that it needs to be taken seriously. But we'll also see what happens too, because the National Space Council was reinstated by Herbert Walker Bush from '89 to '93, and basically all they did was meet and talk to each other, and not particularly much else other than that. I feel personally the jury's still out on that because we don't know the effectivity of it until it actually starts meeting. But I guess we'll find out, hopefully sooner rather than later.
Your thoughts?
Nope. Mike?
Well, I mean, let's not forget why the National Space Council was created in the first place, which was to advise Reagan about the whole Star Wars program and the part of the Cold War, and how NASA and the space part of the Department of Defense would play a role in the Cold War. So that was the whole point in the first place. So without that same type of kind of political scenario with Herbert Walker Bush, and without that same sort of scenario now with Trump, I'm just really curious to see who else gets appointed to the council and what type of political body it will actually be. So we'll see.
All right. Yeah. I think we're all in let's wait and see what actually happens here. Next up.
From a Vogan off of YouTube. Says, defining quote-unquote space might be irrelevant for overview tourists and might be impossible to define scientifically, but it is needed for legal reasons because of the human being's capability to argue with each other. Rather like the law of the sea, another specifically nebulous term, when Ben pays $200,000 for a trip to space and is told by his supplier to go out back and bounce up and down on the space trampoline, he'll need redress for fraud based on legal definition of space.
I mean, I guess it really comes down to using the Kármán line as that definition of space. And I see why it is elegant and everyone wants this definition. But if you're taking a suborbital flight to space and you only go 80 kilometers versus 100, did you not make it to space? Especially since if we're talking about where, where a lifting body will no longer operate and you need the centrifugal force to push you forward, that actually could be at 80 kilometers. So are you not in space at that point? And if we're talking about atmosphere, then one could argue you need to be, it's something ridiculous, like 2/3 of the way to the moon before there was like no Earth atmosphere left, or it's that may not be it. Don't quote me on that.
Yeah, it's a little too far.
I said that, and then my brain was like, still no. But it's still a lot. Like the ISS is still within the protection of our magnetosphere. Is the ISS in space at that point, right? So why are we drawing this arbitrary line at 100 kilometers when even that is like, well, go ahead, Dave, go ahead. No, just say it, and our mics will kind of pick it up.
So the Kármán line actually is that level approximately, because there's a wide band there.
That's my point. There's a wide band there.
There is a wide band there, but it is, the 100 kilometers is the round number nearest to where a wing can be effective at any speed less than orbital velocity.
So here's my argument against it, which is you know what? We're going to have an entire show on this someday.
We will.
I will get, I realize the entire space community is against me on this one, but you hear my argument out and see if it makes sense. So later, you get it in bits and pieces at each individual show. I don't want to debate Dave.
I think we need Dave in that roundtable.
Yeah, we need Dave. No, we're not going to.
Here's a good reason why you don't want a formal definition of space. The United States government flies satellites a little too low from time to time and does not want to get into a mess with airspace rights.
That makes sense. Yeah, I realized you were boosting my mic, so I had to very slowly. All right, so
we'll table all of this discussion for another time.
One other quick thought, if I may, real quick, is that some people might be in it for the arbitrary line. You know, for people who've actually signed up for space tourism with Virgin Galactic, you know, some of them might be in it to get those honorary astronaut wings and have that title of that I'm an astronaut and I did it without NASA.
I believe the honorary astronaut wings do not. So NASA does it at 100 kilometers,
Through the Air Force,
but the Air Force does it at
50 miles.
50 miles.
Right?
Yeah, right. So
yeah.
So I believe based on that definition, the two players left that will potentially do suborbital flights both would get astronaut wings based on that, right? So. And actually, that's another thing is everyone's like, oh well, you know, 100 is the de facto standard, and no, not. So anyhow,
I believe that was one of the points that it was George Whitesides that we were talking to. You asked something about astronaut wings, and he said yes, we will satisfy that definition in the United States. So it kind of it kind of led everybody to think, well, maybe they're not getting to 100 kilometers, but maybe they'll do 50 miles.
Sure. Anyhow, I don't think that matters because the difference between what is that 100 kilometers is 60 something
62 miles.
62 miles. So the difference between 50 miles and 60 miles from an experience standpoint on a suborbital flight, I would argue, is next to or zero. Right? You're still getting the overview effect. You're still experiencing microgravity. If they didn't tell me that I wasn't like if they said, "Oh, you made it to 62 miles or 100 kilometers," and I didn't know, and we didn't actually, and we missed it, I don't think I would have any way of knowing that I actually missed it. I think having never done it before, my argument, right? Because I don't actually know until I do it. I would argue that the experience is near, if not identical. I could be wrong. I openly admit I could be wrong.
So you just need to send me on both. And
yeah, send me on both. I'll tell you. I'll let you know. I'll let you know how they go. All right, next up.
Next up comes off of Twitter from Joey Owen Ye.
And this is in reference to the It's a Test launch from Rocket Lab.
Yep. Says, it was not a barbecue roll, just loose constraints on the roll.
And then there's a bit.ly link that actually goes to a Space News article. And if you scroll down almost to the bottom of the article, one of the questions was some video from the first test launch showed the vehicle rolling when it climbed off the pad. Was it an issue or expected? And basically it said, it was expected. Like we wanted to get some more data, so we didn't null out that roll. It sounds like they may actually decide to zero it out in the future. So if you want to read the whole comment, head on over to Space News. It's actually a really great interview, I thought, with Peter Beck, who is the CEO of Rocket Lab. He's CEO, right? Yeah. Okay.
At least founder.
Yeah, absolutely. All right, and.
Next one comes off of YouTube from Martian Assassin. It says, I would wish the show would take itself more seriously. The show has gotten pretty weird and unbearable for me to watch as it is anymore, though I have been a dedicated viewer for a few years. The show has gotten so weird that I am embarrassed to watch it in public. This doesn't help make space more popular when the show is alienating regular people like myself. This might be very well an unpopular opinion, and I'm ready to be downvoted, but for God's sake, your co-host is a Mohawk and you often wear a Disney shirt, and it just sends the wrong signal, which makes it impossible for me to recommend the show or to view it in public. I love everything space, and I wish the best for the show and the community. I hope I have been fair in my points, and I wish tomorrow the best.
Yeah, I mean, we actually took this comment quite seriously, and there were a lot of people who actually agreed. So I don't want to say this was a wake-up call. Here's the thing. We tweak and play with the show often, and you may have noticed that we tweaked and played with this show based on a lot of this feedback from YouTube. So this specific episode, we made a lot of changes based on that. We do appreciate constructive criticism, and I think most of this was constructive, and I think there were a lot of really great points to be taken out of that. We tried to strike a balance. We don't want to be a boring talk show like you would see. I'm going to use this as an example, but like NASA, right? Mm-hmm. NASA has they're not here to market to us, and they're not bad at it, but their shows are generally fairly boring. They're just not interesting or they're for children, and that's not who we are. We're here to have a conversation about space. We want to be conversational. And we've been playing with the first segment. You've seen us play with the intro, and the intro sets the stage for the entire show. And when we did that, it didn't quite sit right. So we tweaked it again for this show, and I'd be willing to bet I think it worked a lot better, but we're going to continue to tweak it and play with it. The one thing I do disagree with is that you love Disney, I love Disney. You have a mohawk.
Yeah.
There is nothing wrong with that whatsoever. I love the idea that we don't wear suits and ties on the show. Dave and I just had an interview in t-shirts and shorts and jeans. You have a mohawk, just like a mohawk guy from JPL.
Yeah, go back.
Space is for everyone. Space is not just for the elite. It's not just for a certain group of people. It's for people who love Disney. It's for people who have mohawks. It's for people who care. It's for absolutely everyone. And there should be no being ashamed of this show for us being who we are and for us being normal people. It should be more powerful to the show because we are normal people. We're not an elite group. And we don't want to be an elite group. We want to welcome absolutely everybody in here, which means you're going to have all walks of life in this show. And I think that shows the power of the show. That shows the power of space and the unifying aspect of space more than anything else. That was not your point. I get that. So I am digging into this much deeper, and I realize that was not the intent of your criticism. All I'm saying is that's the point of the show. So not only will we not change that part of the show, we will actually embrace that part of the show and push it further, because space is for everyone, not just who we think fits our mold of who it should be. So I took that a bit far. Having said that, your other points I think are valid. I think we do need to continue to play with the show. News is the hardest part. We were talking about this morning. It's because we want to strike a conversational tone, right? I mean, why is this show live if we're just going to talk to you? If we're not going to interact with you, that makes no sense whatsoever. Why go to all of the pains of making this show live if there's no conversation? The thing is, news is inherently not that conversational. So we are desperately trying to find the right balance there. We took the conversation out of the news this week. I would like to try to figure out how to roll a little bit of it back in. I don't know where that dial needs to be. We had gone too far one direction. We'll kind of come back the other way. Hopefully we won't swing too far the other direction. We will figure it out, but constructive criticism really helps. The only thing I ask, make sure to follow rule number 1. You are free to debate the idea of the show or the idea of what we are doing at any time, but never take personal attacks. That's my only request. All right, that is my soapbox. That is my feeling on that, and I thought it was appropriate to bring it up because I thought there were a lot of good points there. Do you guys have anything to add?
I'm not cutting my hair.
You did cut your hair.
I did cut my hair, but I'm not getting rid of my mohawk.
You say
very
that.
Sorry that you
say that, but yes, you are. There will be a time in the future where you have cut it off on the show, like not on the show.
Yeah, well, that was because I made mistakes. Like the last time I shaved my head, the sides of it to keep it nice and clean and professional looking, and I accidentally cut into half of it, and it's like I can't have a mohawk with a chunk missing in it, I haven't been in battle or anything like that.
I'm going to do it the next week after.
Yeah, so it was just do I live with the shame or do I just get rid of it and rebuild it? And it was just rebuild it. So yeah.
I am Groot.
Yeah, exactly. And sometimes you have to start little beginnings to make big.
You shouldn't have to, and that's the thing is we are going to be be ourselves on the show. We are not acting on this show. What you see is what you get. When you meet us in person, this is how we act.
Yeah.
That is both a pro and a con. One last point is that I think you can grow into and back out of this show. What I think might happen for some people is the show can get you excited about space again, and we have this really difficult line of trying to follow it, how technical do you get versus how technical don't you get? The more technical you get, the more of the geeks you can pull into the show, And the more exciting sometimes it can be when you turn the knob towards technical, but the barrier to entry becomes very, very large because you have to understand the acronyms, you have to understand the terminology. So it gets complicated. So then you turn that knob back towards, okay, well, let's make it easier and lower that barrier of entry. But now you're explaining everything, and the people who already know that stuff, they're bored silly because they already know it. So it's extremely difficult to constantly walk this line of how far off to the technical side do we go, how far off to the, and we kind of, you see us drift back and forth on this particular line. I don't know what the answer is, by the way. I have no idea. I have not actually found the proper balance. I think on a per show basis, we make a decision where to go there. The point is, you can kind of like fall in love with space again, learn all the terminology, but if we kind of straddle that line. If you move past us on this side of the line, you can actually outgrow the show, and then you can grow into a different show. And actually, I welcome another great show, a podcast, is the Orbital Mechanics. As you outgrow this show, you can easily grow into the Orbital Mechanics. I feel like that's the next step above a TMRO. If you're not already subscribed to Orbital Mechanics, absolutely do that. And there are other shows like that on the internet. There's nothing quite like TMRO. But there are definitely places and destinations for you to go when you're moving past that technical line into the, I want raw acronyms into my brain. That's not us. And when you get there, that's not Orbital Mechanics either, but they're certainly a step closer in that direction, if that makes sense.
We went plaid.
We went plaid. All right. And fine. Did you have anything to add?
I was wondering if Mike had anything else.
Mike?
I feel like the only time because I understand that whole conflict of how far and how technical do we get with stuff, and I feel like as long as I can show something visual, even if I am spouting off a bunch of numbers or talking about a bunch of different acronyms, as long as I explain what those acronyms are, as long as I can visualize something, then I feel like it's okay to go a little bit technical, so long as that those who aren't as technically versed in something can intuitively understand what I'm talking about based on whatever visuals we might be able to provide. And we're not creating a lot of our own media here. We're kind of at the mercy of the publicly available material that NASA puts out and other space agencies and companies around the world. But everything that we are using is stuff that's in the public domain, and we have to be really careful about what's copywritten and what's not. So, I feel like as long as we can visualize stuff, then it's okay to go a little technical. But otherwise, I still don't know what that balance is, what that perfect balance is, so that you're not over-explaining everything all the time.
Right.
And
but you still have to allow new viewers in, right? We always want to let new people and we want to get new people excited about space. So you can't not explain it, but if we're getting the balance wrong, certainly let us know. The chat room seems to think that we're doing an okay job, and they like certain aspects of it. Like, we do allow the use of acronyms, you just have to explain what it is. Yeah. And that only takes us a fraction of a second, right? Certainly, leave your feedback. Again, just follow rule number 1. I think that's really important. What kind of sets us apart.
Rule number 1 is don't die.
Oh yeah, that's
right.
That
is an important.
You're right. That is
so
rule number 1.
So definitely follow rule number 1.
What is it? Is it rule number 2?
Yeah, you're referencing 2 and 3.
Sorry, you're right.
Make sure that unless your name really is Richard, you're not being a Richard, and then don't. You only debate the idea, not the person.
Yeah, and don't be a troll. So, and I will say the TMRO community is amazing online, and even the criticism was very respectful. Like, I'm really sorry to criticize, and hopefully you don't take offense to how deep I dug into that middle section. Again, understanding that's not what you meant, but I wanted to use that to exemplify how we view the show. I can't read any of that data.
It's the rules.
Oh, it's the rule. It's the rule. All right, cool. Mm-hmm. You stopped at 4. There is actually 5 rules. All right, and next up.
What? Rule number 5 doesn't exist.
Rule number 5.
The last comment comes off of YouTube from Stephen Thompson. What if someone hand wrote a comment and snail mailed it to you? Would that be special enough for you to show it on air, or would you not want to set a precedent?
No. So that's not how this works. So I'll give you the basic idea of how a comment makes it into the show. First and foremost, is it good and does it contribute to the conversation? That is the most important part of the comment. Mm-hmm. If it's like, first, not making it into the show. If If it's just something that we've covered many times before, it's not making it into the show. If you're contributing to the conversation, you don't even have to agree with us, right? In fact,
we had a comment today that didn't agree.
No, you don't have to agree with us, and that's totally okay. Just follow the rules, right? Don't go. Just be respectful. Be respectful. Don't agree. That's totally cool. You probably make it in because now we've got something to talk about.
Yeah.
That's the second part of the comment. If it gives us something to talk about and be conversational, probably going to make it into the show. The third part, and this is the part that is very hard for people, and I'll admit this is hard. Don't make it a wall of text. If you can't make your point in 2 small sentences or less, and you have to go on for a page, chances are I can't condense that into something that we can explain on the show either. It's probably not going to make it into the show. Don't make it a wall of text. Exactly. So there you go. All right.
The only walls of text that are allowed are our Patreon.
Our
so
Patreon.
That's it.
Exactly.
Yeah.
And they are becoming larger and larger walls of text. So short, succinct ideas. Handwritten, I don't care, right? You mail it to us, that's fine. Twitter, Patreon, any social channel, we scour for these things, and we look for the really good ones that engage the conversation and continue it. Whether it agrees with us, doesn't agree with us, or is a different opinion that we maybe hadn't looked at before. That's how you make it into the show. So, all right, speaking of, that is our show for this week. Next week, we've actually got Stuart Money. He's the founder and CEO. Actually, I have a slate for that, Dutta, if it made it into the rundown by chance. I realize that you're all ready for ground support, but he's the founder and CEO of Interspace.net and the Interspace Brewing Company. He's also the author of Here Be Dragons, The Rise of SpaceX and the Journey to Mars, which means we're going to be talking about the rise of SpaceX on next week's show. I'm super excited for that. By the way, Jared, you will be hosting next week's show.
I somehow figured
that
was going to end up happening. So
there you go. So there's Here Be Dragons. It's an Apogee book. So if you guys want to brush up on it before the show, reach out, see if you can grab that Apogee book. That's at apogeespace.com, I believe, or I think it's CMG Publishing. Just search for Here Be Dragons, Here Be Dragons, and then Stuart Money, and you'll find it on the Google. All right, that's our show. I also want to thank the patrons of tomorrow who've helped to make this specific segment happen. These are our ground support patrons that have contributed between 1 penny and $2.49. They get the name of the show in this segment. You're also going to get access to those After Dark segments as soon as they're available on demand. Thank you guys all so much for watching. It's been a lot of fun. After Dark is up next. Is there a good technical reason to start with one versus the other? I guess I haven't thought this through. So we're figuring out. Go ahead.
I'll be right back, actually.
All right.
Go ahead.
All right. Last week we took the news that we missed and did it in After Dark. We're going to do the same thing, and then what we do is we extract that and post them as individual segments on our YouTube page, and people seem to generally like it. I need to work on, and I haven't done it for this week. I'm sorry in advance, it's going to suck again. I need to work on my intros and outros out of those segments because it's kind of painful, and you need to come up with a system for those. But we'll do the same thing again this week. Did it work for you guys? Because I kind of decided, hey, we're going to hit break here, and I moved those objects out of the rundown. Did it move in your rundowns as well?
Yeah, it did. Scared the crap out of me because
Yeah.
I'd just seen it, and then I
It,
went back
disappeared?
up, and then went back down again, and it was like, and we are going to a break. Sorry.
Was that not ideal? I just kind of did it.
It was fine. The
You just
thing
wanted
that this program doesn't let us do is talk to each other in the rundown. So you
What's
moved
interesting-
that,
yeah.
and it was sort of like, oh, where did that go?
Yeah,
And I didn't understand why or what happened.
You're right. It actually does let us talk in the rundown. It doesn't let us talk in the view that we're in.
Sure. Yeah. Switch.
Yeah. I don't have a good workaround for that. I can just add that as a feature request, or we have to use the chat room. But I think you're in main chat. I'm in hosts. I don't know a good way around that. We should talk about that later. Did we get? No,
not yet.
He's just gone for a little bit. And Colton, I'm still getting weird disconnects on the chat room. Like I have to refresh to get
I'm not.
updates.
I'm not.
Oh, all right.
I'm
Huh, interesting.
Yeah, I'm not.
Well, it seems to be, well, all right.
Twicket is asking for just full screens of Jared and Mike when they do their news.
Oh, yeah, that's a good point. Let me align this camera so we can get a nice headshot of Jared, because we don't want to do the group. We do kind of want to make it.
There are no groups here. We are only individuals, or something like that. I don't know. So.
That doesn't work.
No, that's a little far. There's a Dutta.
There's the fire extinguisher. And in case you're wondering,
Very important.
All right, it even tells you.
With me and Dutta
fire
here.
extinguisher.
I'm sorry. Oh, yeah, I don't think that ever really, I think it just sort of got, flight suit debate in the chat room.
There's a flight suit debate?
Sort of.
Okay, that's not going to
There was a conversation about flight suits.
I think thus far we've not mentioned it on the show. It hasn't been part of the news.
What hasn't been part of the news?
SpaceX's news.
Oh, yeah, Space Mike, oh, he's not here.
There's nothing to say.
I know.
There's a single picture.
It doesn't matter, it's still news.
There's a tweet.
Sure.
There's a tweet
somehow
for it.
that.
Look at me, Jared. We'll use this camera for Jared. Okay, thanks.
You're welcome.
I need a little bit of room for your mohawk. Yeah. There you go.
Can you flame on?
What? No.
Like
well,
Jack,
in some circles, I guess,
Jack
my
Jack.
mere existence
I
would be considered
suppose
flaming on.
this is true.
But you know.
All right. Do we have any? I would love suggestions on how to get in and out of these news segments.
Well, it depends. Like, are you hosting it?
Actually, well, that's a great question. I have put this much thought into this right now. So, open.
I
What do
can
we think?
open it if you can figure out how to close it.
Yeah. Okay. Okay. How do I don't even know how to close it. How do I close this?
All right. Pretend Jared just stopped talking. You thank him for that.
Yeah. So thanks, Jared. Thanks, Jared. That was great. Also, I have rockets on my socks. For more info, more news this last week, head on over to Tomorrow Space episode 1032.
Oh, train. I was like, is that a freaking earthquake? What is happening right now?
No, it's just a train.
For more space news and our full show, head on over to Tomorrow Space episode 1032, where we had we talked to Dave Maston. We've also got our live shows every Saturday at 1800 Coordinated Universal Time. See you next week. Something like that?
Sure. Mike, what were you going to say?
I was just going to say, like what you said last time seemed pretty good, and that sounds pretty close to what that was. You know, just something short and sweet. You know, get more news on this last episode, 10.32. Live show every Saturday, 1800. See you next time. Bye.
Yep. Okay. I'm cool with that. And you can get into each one, you think?
I think.
Yeah. It's hard. I struggled so much last week. I'm open to whatever you come up with.
You were doing Jared first or Mike first?
Oh wait, that's a good question. Let's do. You want to do the? It doesn't really matter. You want to do Hurricane? Hurricane is who? Mike.
Mike.
Mm-hmm. You want to do Mike first?
It doesn't. Yeah, it doesn't matter.
Yeah, let's do Mike first.
I mean, it only matters for the live.
Well, I mean, it matters
For
for
the live
Dutta
viewers.
has to.
No,
cue
but
stuff
I
up.
know, but I'm just saying, like, for like the feel and tone of everything, it doesn't.
Sure.
Okay, so who are we doing first?
Let's do Hurricane Harvey. And by the way, people watching live would love feedback on how to better watch this and let me know what you think. But yeah, let's do the Hurricane first.
Space Kyle, yeah, if it's a standalone segment, we definitely need an outro for sure. Think of it like a different variation of a space pod, but just the news part. And Mike went to all black.
Just the TV, not.
Yeah,
just the TV. So
I think I've crimped the.
All right, so if that happens, I shouldn't worry about it.
Yeah. Don't make mention of it. I think it's.
I won't.
I think it's this part here.
Ow!
That part of the part down below. All right, ready?
Sure. Going to black and then coming up on that camera?
No, I think we don't need to go to black. I cut it. I just slice it out. So
Okay.
Whenever you're ready, just start right on 2.
And we're doing Mike first.
We're doing Mike first. Yeah.
Perfect.
So yeah,
Okay.
whenever you're ready.
Yeah, I have to figure out what the very first thing out of my mouth is going to be, unfortunately.
Oh, and if it helps, we'll do the tomorrow, like we do the little tomorrow logo. It goes "Foosh tomorrow."
Right.
Yep, that one. Mm-hmm.
All right. So as part of our conversation in the news section, there were a couple things that we didn't actually get to, so we're going to give them to you now in little shorter spurts. Mike, talk to us a little bit about Hurricane Harvey and how it's affecting NASA right now.
So yeah, as many of you watching have probably heard, Hurricane Harvey hit the east coast of Texas this week and has been causing lots of damage. And just south of Houston, one of the major cities in Texas that have been hit the hardest, just so happens to be NASA's Johnson Space Center, where the American Mission Control for the International Space Center is located. And go ahead and roll this video that has been collected. NASA and a lot of other government agencies and partnerships, including the National Oceanic and Atmospheric Administration, the NOAA, have been using satellite and radar imagery to track the path of the storm, as well as get all the data on the rainfall, the raising water levels, wind speeds, and etc., to help all of the emergency personnel and government agencies respond to this national disaster. Now, going back to Houston and NASA's Johnson Space Center, there was a couple images that were taken by an ESA astronaut, the European Space Agency astronaut, Thomas Pesquet, who is currently at NASA Johnson, and they've been saying that essentially NASA Johnson is flooded, and flight controllers and other essential personnel are camping out there in mission control. You can see a little makeshift bed that they already have there. And thankfully, they've been able to maintain contact with the International Space Station despite being on an island there. They have their own independent generators and have the electricity and the bandwidth needed to stay in contact with the International Space Station. Now, despite the controllers still being there and who's going to stay there through over the weekend, NASA Johnson is officially closed until at least Monday. And after Monday, they're going to take it from a day-to-day basis to see whether or not it's safe for other NASA employees to either come to NASA Johnson or for the people who are already there to leave NASA Johnson. So in any case, they're over this weekend, something that they're doing today actually is they're going to be watching some thruster firings at the station to raise the station's orbit slightly, which will put it in the proper trajectory needed for 3 crew members to depart next Saturday to land in Kazakhstan. So with that whole thing going on, and although the flooding around NASA Johnson hasn't reached any critical buildings yet, there is something I did want to mention that's going on there. NASA's James Webb Space Telescope, the $8.6 billion successor to the Hubble Space Telescope, is sealed in one of the huge thermal vacuum chambers at Johnson for extensive pre-flight tests. And so far, NASA has said that the weather isn't going to be posing any threats, and even though it's very costly, that they have no concerns, which, despite my trust and faith in NASA, suddenly makes me very concerned. But aside from that, and with the whole contact going on, there's lots of other mission control centers all over the world. There is the Korolyov Mission Control Center, Russia's Mission Control Center, which is near Moscow, which can stay in contact with the International Space Station, as well as the European Columbus Control Center, which is it's near Munich, Germany, and there's also, of course, the Tsukuba Space Center near Tokyo, Japan, all which are the other primary mission controllers for the International Space Station. So even if worst case scenario happened and they lost power completely at NASA Johnson, we don't have anything to worry about with the International Space Station and losing control or it suddenly starting to, you know, just go out of control and put the astronauts at risk there. So everything's going to be fine, even if a worst-case scenario plays out. But I thought it was still really cool and really admirable that the people who have kind of gotten stuck there are doing so willingly and are working hard through all of this to keep things going.
You may not know the answer to this, but let's just say Johnson Space Center did go dark. While there are other NASA mission control center or mission control centers around the world, would there be a small gap in coverage as the orbiting laboratory goes around? Like, would they no longer have any coverage over the U.S. for like 15 minutes or something like that?
Not necessarily. There actually are other
Like ground
I don't know
stations?
the exact word to say it, but there's other stations around the United States. Like, of course, there's NASA Kennedy that has a connection to the International Space Station. In Canada, they have their Mission Control Center, but that's usually just to do stuff with the Canadian robotic arm. But that is another United States, or excuse me, North American spot where they can have control for it. And I believe that there's also a kind of backup facility near White Sands, New Mexico. So there's a couple other facilities that, although aren't used primarily, are available in the United States and at least North America to continue coverage if NASA Johnson does completely go dark.
Great. Thank you so much, Space Mike. All right, that's a quick little news snippet. If you want more news, head on over to Space Tomorrow Orbit 10. I almost said Space Vidcast. Tomorrow Orbit 10, episode 32 with us last week. We had a bunch of other space news, as well as special guest Dave Maston, who came on to talk about mass and space systems. Also, don't forget to like and subscribe to our channel. That helps us a great deal on YouTube. And remember to watch our next live show. That's every Saturday at 1800 Coordinated Universal Time. And I should actually, if I were smart, I would actually end with our guest for next week, right?
Might help.
Right? Because that would be a promo. That's a promo for next week. I
Right.
should use it as an opportunity to promote the next show. All right. We'll leave that one as is, but I feel like I could have done. I
feel
wow,
like I
did
could
I
have done
blunder
way
that?
better,
Space Vidcast. It's your fault. It's your fault. We know because he reminds me of Space Vidcast. That's like, yeah. So I blame you.
Well, and everything's his fault in general, so.
Yeah, exactly. Exactly.
What about Carrie Ann's suggesting that in case you missed this last show, we covered other news topics, and we had Dave Maston and blah blah blah, but we didn't. Here is a story we didn't have time to get to, and then go into Mike's story, and then you close it out by suggesting they tune in next week and plug that guest.
Well, I do want to plug the other show as well, so that they can go back to the show.
Right. Carrie Ann, do that.
Right. If I do that at the top, I'm not against this rundown, but this is where the Google Docs would be really nice because then I could just. Blah, 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 blah.
Sure. So the end slate can only happen in the last 20 seconds on YouTube. I can't put one in the beginning, unless I'm not understanding.
Yeah. What are you talking about right now?
So the reason I'm doing at the end the 1032 also next week is
let Carrie Ann do the details of it, but you mention it. You can also watch last week's show here, and catch us tomorrow. Catch us on every Saturday at 1800. Blah blah blah.
Yes.
Make a quick mention of it, but let Carrie Ann do
at the end or at the
cover
beginning?
the stuff that was in this show, and then do the news section.
Right, but I can only put the slate at the end.
Understood.
And we want a good amount of time on, like we want 20 seconds of time on that slate so they have time to interact with the
You
object.
can't talk about the next show and all the opportunities in 20 seconds?
No,
you have to include last week's show?
We should,
Well,
because
with
there's an object for last week's show
right.
on the slate.
And
so I want to reference the thing that's on the screen. That's my point. Right?
I mean, he can still do it at the end. I mean, ultimately, that's what he wants.
No, what I'm saying is that
with the banner that you've created, you'll have a link on one side to the previous episode, and then you can have a link on the opposite side that'll be for the next episode.
Yep, we've got like those. Well, we can't. Actually, I can't. YouTube does not let you link to a future live event. I tried that.
Well, right. You have to link it to the one that we would upload later. Like that would be a future link. Like
right. So
unless it's a link to our website, because we can have a third-party link to go directly to the tomorrow.tv.
So
that's what that link is.
The left box is us talking. The right box is the previous show, the 1032. We have the social media stuff on the bottom and the subscribe button in the middle. So what I'm trying to do is at the end, I want to reference everything that's on that slate because that's what's on the screen right now. So if I'm only talking about future stuff, I'm not talking about anything that's on the screen right now, that's weird. That's my point.
Right. That's fine.
No, I'm asking if I'm wrong. Am I not thinking this through correctly?
I think it's fine. I think it's fine.
My thinking was to bookend the news segment with the live shows. So you're plugging the live show. You've got a link for the on-demand 1032 that Carrie Ann already went over the details of.
Sure.
In the very beginning.
Yep.
So you just need a mention. Here's last week's show, and join us. Blah 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 for next week's show. We've got this guest. We've got that guest, adding that data in there reduces your time to be able to talk about the last show.
So I guess my only argument is there's nothing on the screen that can talk about the future show. So I don't want to spend too much time. I just want to use it as a snippet. I think what we really need to do is create a third object that's not going to happen today, which is a promo for next week's show. It's nothing but a promo for next week's show.
How do you do a promo for a guest we haven't had yet?
Well, I already have a slate, right? We can talk about what's coming up. Just say, hey, join us, blah, blah, blah. But that's why we're not doing it this week.
Okay.
I mean, you see these promos on television all the time.
Yeah.
Yeah, that's how we do it. All right.
I'm thinking for
maybe that's another way to.
I'm thinking for
pressure, I guess.
I'm thinking for continuity of time. At the beginning of this cut out news segment, have Carrie Ann talk about what you missed by not seeing this show.
Oh no, I definitely don't. So
no, not in that sense. But
here's the thing: we need to get straight into it. We cannot spend more than about 10 seconds getting into this.
Cool.
Otherwise, we've lost the viewer.
All right.
Right? Correct me correct me if I'm wrong, but we need to be like, that's why the intro is scary short, right? It's like 3 seconds, and then boom, here's a thing you missed. This is what we're talking about right now. And then at the end, we can be like, oh, here's other stuff. But I don't believe we should do that up front.
Okay.
Unless anyone... I'm just making this up as I go, right? I'm not an expert. Mike? Actually, you seem to be...
No more than just a couple of seconds, just like, So we talked about some really cool stuff in After Dark, talked about Cassini, maybe a space plane, but there were some other things that we didn't get around to, and so tell us about this thing that's going on with Hurricane Hardy. What's up? So like that's 10 seconds, and that's it. So like if we're going to give information on what we talked about in 1032, no more than just a real quick, mention. So I think that you're right, Ben. I think that you're both right in the sense that we need to quickly get into it and not spend too much time on an intro, but also give just a quick little snippet so that, later, since we mentioned episode 10.32, and for someone who's just watching this video, like, oh, they talked about Cassini on their last episode, that's cool. And then at the end of it, see the link there leading to 10.32.
Do you think that's...
Does that make sense?
Yes, it does. Do you think you can work in a really quick... I already forgot what you said on this last one.
I think I can.
Okay. All right, let's give it a shot.
You ready?
Yeah. Am I going to be talking into the camera?
Yeah, you're talking
to... I talk to you guys about it?
Both, but actually, no. Use your camera.
Okay.
Talk to the audience.
Do you want me to not be in the shot?
No, you can be in the two shot. No, it's okay because it's established on the. So we'll establish on this shot. We'll go. And then once we're done establishing, you'll go back over here, do your thing, and then at the end you can come back to us and we can have kind of that conversation.
That's
if you have
good.
a question, anything like that. Again, I don't know. I'm just making this up as we go.
Someone give him Mark.
Are you only going to be looking at him while I'm looking at this camera?
I'm looking at both of you.
Okay, great.
Where?
Yeah, I know.
What do I do with my hand?
Where? I'm looking at nothing.
I don't know what to do with my hand.
Where?
That didn't help.
Oh.
All right, give me a second.
Sorry.
It's all right. Welcome back to the conversation. On episode 10.32, we talked about a lot of things featuring Dave Maston of Maston Space Systems, but one of the things we didn't get to was this news story by Jared. Jared, tell me a little bit more about the neutron stars and their little dance.
Yeah, so I really don't like spreading rumors. So here's a rumor about a potential discovery from LIGO, which is the Laser Interferometer Gravitational Wave Observatory. We've got two of them, one in Hanford, Washington, another in Louisiana. Also, Europe has one that's online as well to detect gravitational waves called Virgo. So this this whole mess started on August 17th when J. Craig Wheeler, who's an astronomer at the University of Texas at Austin, tweeted out, "New LIGO data, source with optical counterpart, will blow your socks off." Now, a few other scientists who work on projects on LIGO also tweeted out similar tweets as well. And then all of a sudden, all these tweets were deleted very, very quickly by everybody. Now, what is so big about an optical counterpart? Because that was the thing that everyone was really sort of talking about. Well, an optical counterpart basically means that something that caused the gravitational waves that we detected has actually been seen in the electromagnetic spectrum. So anywhere ranging from radio all the way up to gamma rays. So the three gravitational waves that have been detected before this do not have optical counterparts that we can actually see. So this would be a very big deal with it as well. Now, a lot of these tweets were citing this galaxy in this image right here, which is very conveniently named NGC 4993, and it is 130 million light years away from us. So that's quite far. And a horrible name. And a horrible name for it. We'll just call it Bartholomew for now. So in this galaxy, Bartholomew, this galaxy has come under the scrutiny of many scientists because the the day after this flurry of tweets came out and then was promptly deleted, public records show that NASA's Fermi Gamma Ray Space Telescope was looking at this galaxy. And then all of the sudden, the next day, the Hubble Space Telescope was looking at this galaxy. And that same day, the Chandra X-ray Observatory was looking at this galaxy. And in fact, in the proposal that was written up to use Chandra, it actually says, in order to verify potential optical counterpart from LIGO Virgo detection. So suddenly this secret thing that had actually occurred that we really shouldn't have talked about, yeah, they actually just put it right in writing on the actual proposal for the thing. So the European Southern Observatory's Very Large Telescope has also looked at NGC 4993, and basically the rumor mill has sort of gone from rumor mill to, yeah, they're probably looking at an optical counterpart. And it's very exciting because this is the first time that we are going to actually have a optical counterpart to go with a gravitational wave. And very specifically with this too, because of the space telescopes that were specifically looking at the object, we can infer from that that this was a collision between two neutron stars, basically two neutron stars spiraling into each other and then eventually merging. And that's what generated these gravitational waves that were detected. The three previous gravitational waves before this were black holes that were actually spiraling into each other to merge. So spiraling neutron stars merging together is something that we have hypothesized should happen in the universe, and this would be one of the first direct detections of that. And it's a very exciting way that we were able to do that, especially because these types of mergers are not as energetic as black holes merging together. So the gravitational waves from two neutron stars merging together is radically different from what you would find in black holes, and it requires a level of proficiency in understanding what a gravitational wave should look like. So this means that not only did we detect these waves, we actually have the ability to detect them, and that's just as important as actually detecting the wave itself. So some really, really cool stuff. And then just the final bit that I always like to throw in here about these gravitational waves is that Einstein's theory of relativity says that this should occur. So that means this is another mark up that says Einstein's theory of general relativity is true. And the reason that that is such a significant thing is because we actually have not had a single piece of evidence say that the theory of general relativity doesn't work. And that's really weird, because in most things in science, you present it, you test it, you look at how it compares to nature, and then if you need to make modifications, you figure out how to make those modifications. With the theory of general relativity, which, by the way, was proposed in 1916, so it's not like this is a brand new thing that just came out of nowhere. You know, it's over 101 years old. It's perfect so far. this is really weird. This doesn't happen in science very often.
Didn't someone like Einstein also say, like, with gravitational waves, we would probably never be able to measure
That was
them?
Einstein himself.
Yeah.
He said that the waves are so small because these waves that we're detecting are basically moving space-time and distorting it at about 1,000th the width of a proton. So not just an atomic particle, a subatomic particle, break that up 1,000 times in 1,000 equal pieces, and only one of those 1,000 equal pieces is the actual movement that we are, or distortion, if you will, that we are detecting. And Einstein said we're probably never going to have the instrumentation to actually do that.
And here we have the instrumentation.
And here we are doing it.
That's pretty incredible. I can only imagine what we'll be able to do in the future.
Yeah, that'd be pretty sweet.
Awesome. Thank you so much, Jared. For more news, head on over to our archived episode of 10.32. We've got additional news items in there. We've also had a great interview with Dave Maston. And coming up next week at 1800 Coordinated Universal Time this Saturday, we've got Stuart Money, the founder and CEO of Innerspace.net. He wrote a book called Here Be Dragons, The Rise of SpaceX and the Journey to Mars. And we're going to be talking all about SpaceX. Don't forget to subscribe and like this episode, and stay tuned for next week's show. Better? I feel like I'm not needed for this. I feel like I can exit this and you guys can take this. Right?
Like we could almost do it ourselves.
Well,
I
yeah,
mean,
you
you're
don't
part of the
like,
show.
I mean, I'm not part of news. I feel like we should take my
chair.
chair.
You are part of the show.
I am a part of the show. Well, we can debate that later. But anyhow, I thought that was good. There you go. I think, what else do we want for... We're keeping Dave from his vacation.
My only complaint for that was that we had the leaf blowers downstairs.
Yeah, I mean that.
There's only so much we can do about that.
Is what it is. Yeah, I'm not gonna stuff in things there. Dave, any other cool things we should be talking to you about?
He's like, nothing I can say on camera.
Just ITAR redacted.
You know what we need to do next time Dave is on in like 10 months? Instead of just having an interview with Dave, we should have the interview with Dave, but it should have a little tub in the middle between us, filled with Lego. And just build something while we talk and just see what he comes up with.
You don't have to ask him to do that. You understand that, right?
Oh, no, it would be inferred. It would be inferred.
It's
yeah.
obvious. One of the first pictures I have of Dave is him with a gigantic pile of Legos.
Yeah?
South by Southwest 2010.
Yeah, oh, yeah.
We came across a huge pile of Legos, and then one weird little corner of the convention center.
I got it. So we'll have a big thing of Lego sitting in front of Dave, and he'll just be messing with Lego. And if he's ever like, I can't really talk about that, I'll have a Furby that I'll just take out from behind my chair and be like, are you sure you can't talk about that? Oh, that was it, a Tribble. I'm sorry, a Tribble,
Yeah,
not
it
a
was
Furby.
like,
a Tribble.
what? Why a Furby? Tribble.
Yeah. Like what?
Yeah, no joke. That would not be a thing.
The story that was it. South by Southwest. No, not South by Southwest. It was Space Up
Space
DC.
Up DC was the Tribble.
We had
South by Southwest
we
was
had
the logo.
We had a Tribble
Legos.
fight at Space Up DC, and it was
where we almost killed Dave Maston.
We almost killed Dave Maston. I think that's ultimately sums up the story.
That's
well, they
much
were
the whole
soft
thing.
on the outside, but when you throw them with a great deal of force, that little plastic battery pack on the inside, that can hurt.
I think
Who knew a lot of kinetic energy could do that to you? So
I think any interview with Dave Maston needs to be treated a little bit more like Never Have I Ever.
Never have I ever gotten into a Tribble fight with Dave Maston.
No, but I mean, so you can ask him questions or not ask him questions, and sometimes he'll just be like, "Yeah, actually, I can talk more about that," and then other times he'll just be like,
"Neat." That's how I felt. When I'm going into Adam, you can do this really cool things. He's like, "Yeah, that sounds neat."
That's cool.
Let's change topics. I'm like, oh, that was not in my notes of things not to talk about. Whoops. Sorry about that. He was very graceful. I was not.
That's all your fault.
It was.
It's always hilarious when you're having a conversation with somebody that knows something that they can't talk about, classified information from military, etc., and the conversation just comes to an end. You ask a question and they're like,
yeah, you just stop.
Can't talk about
all right,
that sounds cool.
Next.
Yeah, so how's your...
Yeah, I'm fine.
Oh, yeah.
I'm updated.
I don't know why I never update. I just randomly die. Now, if I refresh, We'll come back eventually. And I'll get all the, there you go.
All right, we can let the Mastins go after Dave signs the set.
Oh yeah, that's right. So can we? You want to sign the set? Sure. We can let you guys go. I know you gotta. I don't want to keep you here all day. Let's do it on camera if we can. Dada, do you have a writing utensil?
A Sharpie.
Oh, I need to get a new stupid tripod.
Yeah.
I hate this one so
You want
much.
my Bogan I have at home? I think I have a.
Is it better than this? Is it one of these?
503.
Oh, that's way better.
No, it's like an ENG.
Oh yeah, that's
style.
way better. Are you using it?
No.
Yeah, I would love it because I hate this thing.
And I think it's got the 501 head on it as well.
Yeah, that would be fantastic because this is awful.
Okay.
Okay. Do we have another one? Dave, how do you feel about signing in blood?
Sure.
What the
I didn't hear a no.
Yeah,
I did not hear a no.
He just looked at me like, obviously that's what we're doing.
Just
He's like, we aren't?
Just want to be clear about that.
Oh, I should turn my mic off since it's cookie time.
Do we have anything in here? Okay. Ooh, that was my hip. Or as I say, my hipple region.
Most of those things came from Australia. I wouldn't even.
Don't let Lisa hear you say that.
Yeah.
You know, I should just buy a pack of them so they have colors to play with. And that. I have a pen.
I thought we've played this game before.
Apparently we have.
And
I have a space pen.
Clearly lost.
I have an AG7 space pen. That should work sideways. Oh my God! Yeah.
You can sign this end cap or that end cap over there.
Sorry. Let me see.
Well, this one's visible.
Oh wait.
This is true.
Wait, hang on.
And that's why most people sign that one.
We could watch it. Move the camera so we could watch it.
Yeah. Hit the buttons.
Hit the buttons.
Boop. Hit the. Okay. There
we
you
lost
go.
Dave.
It's funny. You lined it up so it's almost perfectly light side and dark side.
Oh yeah, Dave. Empire or Resistance?
That's a silly question. Really? Everyone's against you, Ben. You know that.
What? No, Empire, right? Empire? Empire. Okay,
Yeah,
just
I'm
making
with
sure.
Empire.
Yeah, Empire.
His nickname?
Darth Maston.
Yes.
Okay, well, I'm just making sure. We're documenting for certain. I'll walk around this way. Dave Maston's with the Empire. All right. Assuming it works. This is going to be interesting because should we go over it with a Sharpie when it's done?
Sure.
Is it actually like writing? Oh, it is. I can see it from here. Hang on. Ooh. Got a little. See if we can.
It's engraved now. Is that what you're saying?
All right, hang on. This is going to be terrible. This is a terrible idea.
So I can do the Maston M.
Oh yeah.
Get some stickers.
There you go. There, now you can actually. There you go. All right, I'm not going to keep you guys here. Are we done with After Dark? Should we? Have we wound down?
Oh, we got plenty of time.
All right, cool.
I mean, you can harass someone after dark.
Do you want to get harassed on After Dark?
Or what do you want to know about Dave Maston?
Oh no.
Oh, yeah. Fireside chat with Dave. Have a seat. Jared, you want to give up your mic?
Oh, yeah.
You don't mind?
I sure can.
I don't. I can move.
No, you can be here. You don't have to.
Okay.
You don't have to. You have to make it pretty for After Dark. There are zero cares for that. Although Carrie had an idea of changing it to Afterburner. No. Bunsen burner? No. Retro burn? Retro?
Mm-hmm.
Yeah, something like that.
Retro rocket?
Retro. Yeah, it's just something along the lines of like retro rocket, retro burn. RTLS.
RTLS is a really bad thing.
Well, I suppose. I know.
RTLS is a really good thing.
No, RTLS is not a really bad thing. Only in shuttle era.
Yeah, see,
Yeah, but again, no. But shuttle did everything wrong. So you don't want to.
Boost back. Yeah, I mean, yeah. Dad
Boost
dog,
back burn. That's
anything
fun.
along those lines.
Yeah, I like that. What do you guys think? Changing the name of After Dark to Boost Back Burn.
Deorbit burn.
Deorbit burn.
Deorbit burn or Boost Back Burn? What do you like? Boost back or deorbit?
Oh man, that's a tough one. That's a tough one because I like both of them. You know,
Yeah, I bet you do.
first stage has to do return to launch site. The second stage has to do a deorbit burn.
I don't know. By the way, Mike, I don't. Mike, you're free to hang or you're free to go at any time. I don't want to stuff in things.
Yeah. Well,
it's because it's Dave, and you want to hang with Dave.
Re-entry burn.
I mean, you guys have pretty much already asked a lot of the questions that I wanted to ask.
I don't like
but,
re-entry burn.
You don't like re-entry.
He also doesn't have an earpiece.
Right.
I don't. Yeah, I don't have an earpiece. I can't hear you.
Oh well, that's okay. But I did just want to say real quickly that I really liked how the rundown went today and how the show went today. So I think we're on to something here.
I like how most of the rundown went today.
Yeah, the inability to chat, is a
really
problem.
annoying.
We need to fix that. But other than that, everything else worked, right?
I think so.
Mm-hmm. All right, so I'll see if we can fix that somehow. That's going to have to not be in the rundown. That's going to have to be like, no, thank you. It'll have to be somewhere else. And then PSN is working on some automation, so it's going to be even cooler when we actually get everything working. You won't have to like worry about your naming conventions at all. It'll just magically work. I know, right? But for now, you have to worry about your naming conventions. But we'll but we'll get it into a position where you just do this. Oh, Mike, I'm sorry. Before we let Mike go, I did one thing. I'd like to work it to the point somehow where you don't have to toss the video to Dada. So I want to make it so you just talk and the video rolls. And I know that you time a lot of things out, so maybe instead of, like if you have a certain part where you have to hit this marker, just make that a second clip, and he can just roll the second clip at that point so that you always hit that marker. Like he'll make sure, and then just put it in your rundown, in your script about where you want it to go.
If you're reading off a script, put your video start where in your script you want the video to start. When you get to it, I'll roll it.
And just make sure that you get those last lines exactly as they are on the script. So when he hears the words something, 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 he knows, oh, I need to roll it now, and he'll go to it. So I don't know how...
That's what I thought we were doing all along.
It is, but you're always...
We didn't have time codes put in there or anything like that, but I just thought that with the placement of where we were putting the videos in our rundowns or pictures or whatever we might be linking, that is where we want it to start playing.
You are, and I think that's exactly what's happening, right? I think the only part I would like to change is the very, very first one. You always announce to Dada, let's roll that video, or you always toss to it, because there's in the script, there's nothing to go from where you're at to that very first video, especially in launches. I don't know what that format will be. I would like to work on that over the next couple of weeks to eliminate the need to cue Dada for that first roll. I think every roll after that has been fine, unless you guys disagree.
He still calls it.
He does?
Yeah.
He did in the After Dark news for sure.
Yeah.
That one I called it because I was already like 3 paragraphs in where I'd already wanted the video to start. So that's why I had called it, because I'd already wanted it.
I actually made note of that too. He was in fact in his script where like he had. Well, hang on. I can see the other side of that as well. You use your script, and this is not wrong. I'm just simply pointing out what I think happened. Your script is not verbatim, if that makes sense, right? You didn't speak exactly the words that were in your script. So you were roughly about where that was, but I don't think there was an exact cue as to where to roll that particular video. That's not wrong. It's just that if that's how we're going to do it, which is fine, we need to come up with some sort of apparent cue, if that makes sense.
Because I noticed with our notes, and we're all doing this, where we'll have a really good notes, but we're not reading them verbatim all the time. We might be sometimes,
right?
But we're not. We're just kind of sticking to that sometimes. And so maybe cues that we do want to have word for word, maybe have that like in bold or something like that, so that that will be the cue to know that, like, okay, when we say these words, when we say the neutron stars colliding together, that's when we can roll the neutron star video, or when I say.
Curly, curly braces.
Sorry?
Curly braces.
Sure, yeah, you can use curlies around the words that you want. Actually, I wouldn't even say that. I would say, like, the last sentence before a roll has to be verbatim and everything else doesn't matter. Right? So, as Dud is looking at the rundown, as long as you say that last sentence exactly as is, he's going to know that last word. He's going to anticipate it, and he's going to be able to hit play. And then from that moment forward, you're good. It's that last sentence. As long as the last sentence before a roll is verbatim for what's in the rundown, I think we'll be okay. Is everyone cool with that? Does that work for you, Dada? Does that work for you?
And I think as far as launches go, I could usually say, like, my first line that I usually say of just like, okay, so we had a launch on this day at this time from this place.
Yeah, I agree. So
roll the video.
I usually just throw in the rundown where I wanted that, and then I just assume that Dada hits it.
He does. It's just a question of if we're, okay. So let's talk to Dave. That's what I want to work towards. It's going to take a little while for us to get there. That was my only note from this show, right? So my only thing, and it's not a big deal. I would like to work towards not having to call the videos. It's just a minor. It's just a minor note. All right. On that note, hi Dave.
Sounds good, though.
Where are you going?
All right, I'll see you guys later.
Oh, you can stay on if you want, Mike. Or you can leave. You can do whatever you want.
I think I'm going to go, but I am going to watch for a little while longer. But yeah, I'm going to go off camera, though.
Where are you going?
Going to Sequoia National Park.
Woo! Nice.
You got to woo.
It's beautiful.
It is. It's incredible up there.
I've never been there personally, but I have friends that have sent me photos from there, and I'm going to try to get there when I do my Yosemite trip next year.
Yeah.
So, yeah.
Off trail.
Off trail.
Yep.
Yes. We're going to start off at Wolverton, walk up to Pear Lake, and that part's on trail. And then we're going to go up onto the Tablelands, which is just like huge expanses of granite with very little else.
I need a new countertop. Could you bring some back for me? Just like huff it. Just like
yeah,
like this.
That's actually illegal.
Yeah,
you're not allowed to even pick up a stone and carry it out with you.
Really?
Yeah.
Wow.
That is,
well, now I want it even more.
And and Tiff and I are really big on the leave no trace. So, and part of leaving no trace is actually leave the stuff that was there when you got there. Except for the obvious trash. That gets picked up and taken out. But
do you clean up after other groups as well, if you ever see something?
Sometimes I do, sometimes I don't. It depends.
What's your? Have you ever had any like wildlife encounters? I realize we're not talking space, but I figured this is this is a major part of your life. So.
6-7 years ago, we did the High Sierra Trail.
Okay.
And we started off in the High Sierra Trail starts off on the west side of Sequoia National Park, in the giant forest. And we had just gotten out of the giant forest. We were walking along. We stopped for a quick bite to eat for lunch. And a bear came wandering up to us as we're finishing our lunch.
It's like, hey, Dave.
And like, I don't know, probably about 20, 30 foot away maybe? Came to a stop, looked at us, and just had this expression on his face like, are you going to invite me to lunch?
Did you invite him to lunch?
No. At that point, he stood up and started explaining to him with a gradually increasing volume to my voice that it would actually be illegal for us to invite him to lunch and that maybe he should go find some food elsewhere to dine on.
Preferably not you.
And yeah, well, it's a black bear. Black bears don't really find humans tasty, apparently.
No, but they like to mess with you a little bit, don't they? If they get, or am I thinking?
You're thinking grizzlies.
Yeah, grizzlies.
yeah. Black bears tend to be afraid of humans. Yeah, so I mean, the fact was, he sort of walked up, was hoping that we would drop something or something, realized we weren't going to do anything, and wandered off. So yeah, just the standing up and talking loudly was like, oh, okay, you're one of them, okay. You're not going to feed me, are you? Okay, I get the idea. Yeah, I wandered off.
You guys do campfires at all, or not? Not so much.
No, we don't do the campfires. Yeah, they're
well, that makes it. Tiff's just said off camera. Right now, they're illegal, which makes a lot, at least here in California.
Well, half of California is already on fire anyway.
You know, California's on fire. It's just like every year.
And somehow I missed the new fires. I know everyone's
Not just
looking
the
at
new fires too, but like San Francisco's like 105 right now.
Smoky Dirk, but black bears do hold a good conversation. Only if you give them a peanut butter sandwich, though, which you were unwilling to do.
That's
apparently.
right. Yeah, not willing to share lunch with them.
It's funny.
And skiing.
So skiing.
Have you been? So Tiff, have you been able to ski recently? Well, I mean.
I mean, I'm technically cleared to. I just don't feel like hauling my skis a couple miles in the backcountry to go skiing.
Sure.
Figure I'll wait until it snows in October, November. Ski. No, I skied until the end of May.
Yep. I skied a couple times in June.
I do kind of miss skiing a little bit. I did a little bit of it back when we were in Minnesota.
What?
Not a lot. More like when I was really young with my. It was more cross country, less like downhill. I never really did any downhill stuff, but that was more like I was this big.
How long have we been married?
Oh, feels like 40, 50 years.
I'm just learning this now.
No, it was God, what was the main drag? Like you would turn up a hill before you would turn onto our end street, and I don't remember what it was. And there were a bunch of buildings there now, but there didn't used to be. And yeah, I remember going up specifically with my grandmother, actually going down, and it's fun. I kind of miss the snow a little bit.
Your grandmother?
I know, right?
Which one?
Father's side.
No.
I know, right?
No.
Yeah. Yeah.
No.
Uh-huh.
No.
Uh-huh.
No.
Uh-huh.
I could do this for a long time.
I kind of miss snow, but I only miss it like fondly until I'm in it, and then I don't want to be in it anymore. So I think I kind of like the idea of going to it and being in it for a little while, and then being like, I'm done with this now, and then leaving. Yeah, I get that.
We do it probably longer than you would, but yeah.
I'd probably what is it?
That's why you live in California.
Yes, why I live in California. It was the National Lampoon's like Christmas Vacation or whatever it was, where he's like at the Grand Canyon. He's like, "Yep, back in the car."
Aerospike Buck Hill is a good guess, but I lived closer to Buck Hill than you did.
Where's Buck Hill?
Really?
Oh, is that the downhill ski thing?
Yeah.
Oh, yeah. No, I wasn't really that close to that. What's your favorite place to go to?
Favorite place to go to? I don't have.
Other than Moon and Mars.
I don't have a favorite place. Anywhere in the Sierra Nevada.
Where do you want to go, other than the Moon and Mars? Actually, no, not other than the Moon and Mars. Let's say the Moon is open up to you. Where would you go on the Moon?
Wherever's open.
So wherever you can get, don't really care.
Yeah, not really. Don't really care too much.
Same thing with Mars. Or
Same thing with Mars. Yeah. Well, I mean, maybe some of the side canyons off Valles Marineris, maybe, or maybe one of the previously water-created canyons. I don't know. But beyond that, I don't know.
When are you building a really big rocket or lander?
So things I can't talk about.
Oh, Dave! Dave!
We've been working on the Zeus lander for ages now, and we're still working on it. Still making progress.
When do we get to see like pictures and progress updates?
When we actually have something, I guess. I mean,
the internet wants to see Zeus.
It's like it's the we're not the kind of company to do the PowerPoint. So when we actually have real stuff to show,
That's a nice little like. I know. Ooh, it's getting hot. It's getting toasty in here. Woo!
we have no artists on hand.
No, we don't want to see artists. That's the point. You've got it there. Take pictures and be like, "Isn't this neat?" Although ITAR, but you know, they relax some of those regulations.
So once we start having building it and are flying it, we'll show more pictures then.
Well, you could do it before you're flying.
Nah.
Oh, you're hurting me, Dave. You're hurting me. Oh my God, you and Jeff Bezos. Hey, even Jeff Bezos is webcasting his launches now. Just saying. I'm just saying. Just saying, Dave. Let me throw that out there.
And they're better than Sierra Nevadas.
Oh, Tiff said they're better than Sierra Nevadas. First off, that wasn't a press event. Like,
I had a great view out my window.
I don't understand why that was live webcast. That it's a captive carry test.
Yeah.
Who cares? I'm sure they care, and I'm happy that they're being transparent about it. But like, neats. Oh man.
It was cool that they were testing the avionics that they're actually going to take to orbit on that.
Sure, but you can't.
I don't know if that was worth a 2-hour webcast.
No.
Fly around underneath the
No,
helicopter.
no. What? Like, I get it. There was like a marketable event out of that. That's maybe 2 minutes long, but not a live webcast. Not for that.
Recap video.
It's a great YouTube recap video. That's exactly what that was. That was not a 2-hour webcast.
But that's a fantastic indication for those that are interested in the
There you go.
in the captive release
And
test.
our flights have gotten too boring.
Don't use my words against me. That's rule number 6.
Too many, too often. I don't know.
Sure.
Actually,
Oh, you know what?
Mostly, it's
hang
the
on.
customer says we're not wanting to show video until after it's successful.
Okay, that's fine too, but I feel like like we just said, like a live webcast for captive carry doesn't make any sense. I'll take the videos too. I don't seem to remember a whole lot of videos getting released on the. You get a few, a small handful, but I know you're flying a lot more than that.
We are so. Honestly, most of our flights are the tethered flights.
Those, to be fair, those do get a little bit boring.
Those are not exciting. Those are not.
I mean, they can be, but they're not the kind of
They can
exciting that you
be.
want to show off. But we want to see anyhow. Hey.
But and then the free flights. We do enough of those, and we do usually get those out. It just sometimes takes our customers, public affairs people, a little bit longer to get those to where we can publish them.
That's fair.
So
I still want to see Zeus. Just saying. I think we'll just stand in uncomfortable. No, you'll win an uncomfortable staring contest. So I don't think I want to. I think I want to do that. Yeah, I saw that up. She pulled up Elon Musk's putting together a blooper reel of the landing. Which is funny because I feel like a good chunk of that's already out there, right? I mean, it's already been released on the SpaceX Twitter account. You can just go to their Twitter account and watch it come in sideways, watch it coming down, and then tip over.
My favorite one is the first attempt where it just comes in at the barge.
Yeah, that's what I say. Yeah, it comes in sideways.
It's not even like attempting to go vertical. It's just like, here it comes. I'm gonna land. No!
Ready for me? I think my favorite was when it landed and it looked like it stuck the landing. You're like, oh, they did it! They did it! They did not.
You mean the one that somebody put like googly eyes and like squiggly arms on it?
Yeah, exactly.
Woo! That one thruster firing as hard as it can.
Yeah.
No!
Yeah, and it starts immediately. Like it lands, and you see that thruster going like, we're tipping. It's like, stop! Ah! You're not gonna be able to fight the gravity, hon. Anything good from the chat room? No.
For some reason, we're talking about Finland for a while. I think Heldesk asked. I lost it. Heldesk asked for book recommendations from Dave Maston.
Ooh, that's a great question.
I think it was Heldesk.
Although
somebody did.
recommendations.
I think it's going to be like the rocketry.
There we go. Early days in the range of light. I haven't read that one yet. It's on my to read list. I actually backed a Kickstarter by someone that I randomly follow on Twitter, who did a Kickstarter. Said, this amount of money, I'll write a couple of novels. They're actually pretty good. They're very Heinlein-esque. In so many ways. There's definitely a lot of influence from Moon is a Harsh Mistress. It is, Earth in a not too distant future. Suddenly there's a moon colony. Earth politics are difficult for certain types of people. And the colony gets into splitting up. I just got those books. I've read the first one. I'm partway through the second one.
Enjoying them?
And I'm really liking them.
Do you remember the title or the author?
So the Twitter account is Morlock P.
Okay. You can figure it out from there, Internet.
Use
your interneting skills.
From there. It's definitely interesting. But yeah, I don't know that you can actually get those anymore, because like the Kickstarter ended, he self-published, and that was it. That was it to the run. And
although, did he make it like an e-version available, or that was it?
I don't know. I don't know.
Your move, Internet.
So anyway, yeah, Moon is a Harsh Mistress is one of my favorites of all time, I think. All the classics, Asimov, Arthur C. Clarke, they're all great books. Other than that, let's see, Introduction to Algorithms. There's an algorithms book by Knuth.
That seems very boring.
Bell Bruno, Chaotic. I don't remember the title of it. The author's Bell Bruno. Look it up. It has something to do with chaotic and orbit transfers. It's not simple stuff at all. Let's see.
Is it just basically a book of math?
Yes, actually it is. It is a book of math, yeah. It's about orbital transfers. That's it.
Actually, orbital transfers can be kind of interesting, like what you can do just incredible. Gravity is a neat thing.
Yes.
I'll leave it at that. Gravity is a neat thing.
So that's the thing about this book is it's about how you get to doing transfers at very low energy. Mm-hmm. Incredibly low energy. It takes forever to do the transfer, but incredibly low energy transfers throughout the solar system.
Other comments from the commenting internet?
So going back a ways, Dad Dog actually said something interesting about the Kármán line astronaut wings idea. It says, when you hike the switchback trails to the top of Mount Fuji.
Go ahead and push it.
Okay, there you go. They have stations along the way where you stop to rest and get your quote-unquote Fuji stick branded with the station's altitude. Maybe same for space tourists. You can brand their names with the attained altitude, in metric or imperial. But it is an interesting idea.
I would say metric only, although all hail the Empire. So
Sure, but you know what I'm saying.
Yeah, no, that is like how measuring stick of how high you've gone kind of thing. Mm-hmm. And then eventually comes into, how many celestial bodies have you visited? That'd be really cool. Like, oh, well, I've been to the moon and Mars.
Right.
Earth's moon and Mars.
My other home is on the moon.
Kind of. Well, I've got a... Yeah,
right.
Exactly. Yeah. I got to get a place where I've got...
Hey, my own private moon around Jupiter, okay?
There you go.
Yeah.
Richard and his private island.
That's true. I
got a private moon.
Oh yeah, we can ask the question. You can, if he can't answer, he can't answer. So that one comes from
Heliopausing. It says, Dave, please tell us about the computer systems you're using.
Commodore 64.
So yeah. Well, actually, I started off with an Apple II.
Yeah. Did you ever have a Commodore?
I did. I had a Commodore 64, and then it died, and I got a Commodore 128.
Yeah, oh my! It was twice the RAM.
That's right.
128 kilobytes.
Yep.
of RAM. I said that right. Kilobyte. More than you would ever need.
Way more you could ever need. And then
it had the expansion port on the back. You could like put the cartridges in the back. Oh yeah.
Oh, and then I got my 386DX.
Turbo button.
Yeah.
Turbo
yeah,
button. Wait,
turbo
was it
button.
was it 386s? Yeah, the 386 had the turbo button.
They did turbo buttons, yeah. From the, well, we started with 286s, but 386s also had them.
Yep.
Yeah, it was a 25 megahertz system.
More power than you'll ever need.
I got 4 megabytes of RAM on that.
Slow down there.
Yeah.
Keep going. Keep going.
Well, I'm just gonna go ahead and.
Did you ever
cut
have
to
an
the chase.
8088 base system?
Well,
like an original.
So my dad actually had a IBM XT, and I did get to play on it a little bit.
So yes, through just like I had a Commodore 64 in that my dad had a Commodore 64.
Right.
Like.
Well, I mean, I had a Commodore 64 in that the family had
Sure.
a Commodore 64.
Yeah.
Oh, I'll go with that. Yeah. Family Commodore 64, right? Mm-hmm. Yeah.
Well, no, our Commodore 64 literally was the family Commodore 64, and then the IBM XT was Dad's XT.
Gotcha. Yeah.
That, we had to ask special permission to actually do anything on it. And then, when I was like 1 or 2 years in college, I went and got a 386.
All right, so jumping ahead.
So jumping much ahead, we are currently using a lot of time on the supercomputer at one of the big national labs. I'm trying to remember which one it is. So Oak Ridge National Laboratory.
Watson? Is it Watson? You're using Watson.
No, we're not
hey,
using
Watson. How do the fluid dynamics on this look?
No, we're not using Watson, but it's one of the largest computers in the world. Supercomputers.
By speed or by volume?
Yes.
Okay.
Yes. Yes. And during XS1, we had access to all the Air Force main supercomputers. So yeah, we do. I mean,
is it the fluid dynamic computations that you're using?
It's mostly for the fluid dynamics.
That stuff is insane.
Yes, it's insane. Yeah. And we went into CFD on XS1 way earlier than most usually do for a design. Like if you're just at the preliminary design phase, you usually don't use CFD. Like you use CFD when you get into critical design or detailed design. We were, very early in the process we started using the CFD.
This would be known as PDRs and CDRs in the industry. Preliminary design, critical design reviews.
Yeah. Mm-hmm. Yeah, so we actually started using a lot of time on those computers very early in the program.
Why? Why do it differently? Why? Because fluid dynamics is expensive, scary, hard stuff.
So the problem is if there's this wonderful database of how things work aerodynamically.
Is it how things work or how things should work?
Produced by the Air Force, and it's mostly based on empirical data, and it's called DATCOM. And the Air Force, DATCOM's used for most airplanes. There's also a missile DATCOM, which is used for traditional rockets and missiles. And it works great as long as you want to have something close to a traditional shape.
Okay.
If you want to try getting outside of that box, you need to find some other way of figuring out whether it's going to work. And so that's where the CFD came in, and we were able to run a lot of CFD on the supercomputers. And it helps. The CFD package we use, I'll say their name again, NUMECA. NUMECA is actually known more for turbo machinery design, but
that's another. Why I would say that's
fluid dynamics is fluid dynamics. It doesn't matter. It works.
Yeah.
So we had them do some minor tweaks and changes, and we were actually able to do some pretty powerful studies on how to put aerofoils out from the vehicle and make them hook up or not hook up, and came up with some really wild designs, and one of them happened to actually work out really well.
And as you said, you did the wind tunnel test to validate all that, because while the computer simulations will say one thing, they don't always translate into the real world.
CFD has been notorious for saying, "Oh, this is going to work great," and then you make something and it completely fails in a wind tunnel, or just does not work at all in the real world.
Mm-hmm. But it matched up.
But
right?
yeah, we got to match up.
Mm.
It was beautiful.
What was the advantage of breaking from traditional shapes and designs, requiring? What was the advantage of going this alternate route rather than just going for things that we know?
So we actually have a really good lift to drag ratio from that vehicle. So we're actually able to get quite a bit of lift out of it. We didn't need a whole lot of lift, but just got a lot of it. Kept the drag fairly low, got good stability characteristics out of it. It basically got really good flight characteristics from hypersonic velocities, so above Mach 5, up Mach 10, and all the way down into supersonic, transonic, and subsonic. So basically the entire thing. We got able to get some pretty good flight characteristics the entire way down.
Which is a difficult thing, right? Because as you're transitioning from each one of these phases, the characteristics, I'll let you explain, like why is that?
So yeah, your ideal shape is never the same. Especially when you're dealing with hypersonics, it's really difficult because your ideal hypersonic shape is this angle. You look at the Wave Rider shapes that they come out with, and you get one shape at Mach 5, you get a completely different shape at Mach 6. And there is nothing good in there, but you can get something decent.
My understanding, you mentioned you were using fins. My understanding is, and this is a very rudimentary understanding, is if you have a fin on an object and you go, say, transonic to supersonic, the pressure on the fin will actually shift and move.
Yep.
And if you're using that fin for, like if you've got any pivot points on the fin to use it for any form of steering or anything, where you need to potentially pivot actually moves based on where you're at in that regime. So using I assume there's no, you are using it for control. You're using your fins for control.
We do have elevons on okay of them, yes.
But so does that point not move like in a?
Like it moves, but we fix that in software.
Oh, okay. All right.
The nice thing about fully autonomous vehicles, you can just fix that in software.
Not everything can be fixed in software, right? If it doesn't have the articulation necessary to do what you need, that's
that's part of we were able to obtain nice characteristics all the way down. We were able to maintain control and stability the entire. Well, actually, we specifically went with are not stable. We were neutrally stable, or not really stable. We weren't totally unstable, but we actually maintained a much broader range of control by doing that.
Is that Mass and Space Systems like secret sauce? Because a rocket is so much more now than hardware. It's the control software and the automation, and that stuff is not easy.
Being former software guy, I think software has a large part and application to what Maston's doing, and part of the secret sauce. I won't say it's the whole thing, but
other good questions from the chat room.
Let's see.
Hence box or grid fins. Box fins.
No? Are we spinning? I assume this is a not really if we're...
Yeah,
meh.
There's a little bit of a KSB conversation going on.
What are you excited about recently? Like what gets Dave Maston excited? That is an awkward question that I think you know what I meant, not what I said.
What gets me excited? Well, besides my wife. Yes, my wife can still get me excited.
Oh, wow. Making it more awkward.
They've only been married a year. Wait a while.
Yeah, we've only been married for a year. So
we've been married by what feels like 40, 50?
At least.
Yep.
What else gets me excited? Long ski trips into the mountains, long hikes in the mountains, building launch vehicles, designing launch vehicles, Did I mention building launch vehicles?
You enjoy the actual
It's in there
hands-on
somewhere.
building of it as well? I mean, is that...
So I haven't actually done any of that recently, but yeah, I do.
Your 3D printers are doing it for you. You're like watching.
Oh, man.
Actually, it's not even that, right? The bar moves fairly quickly, but then like watching laser go.
Yeah, you watch little sparklies show up all over the place.
It takes forever.
Yeah, no, it's no, yeah, I like designing and building and.
Crazy weird things that haven't been done before. Let's break the mold kind of thing.
Yeah.
And fun when it works and still fun when it doesn't kind of thing. Like,
yeah,
hey,
exactly,
there's something
yeah.
there. All right.
Try new things, try crazy things.
I think we're spinning down. I think we've had a pretty good After Dark. All right.
Yep.
Well, I think that's our After Dark. Thank you everyone for watching. Would love feedback and comments on what you would like to see in news and how we should do that for the smaller clips and other things you want to see us do in the show. Thank you again, Dave, for taking time out of your vacation and popping over last minute to come on the show. It was fun. I hope you guys I hope you had fun. It was pretty cool.
It's terrible, horrible,
hate it.
horrible, terrible.
Hate you guys. All right, that's it for us. We'll see you guys next week.